changes. Is steam flow. And by the time the actual megawatt of your unit reaches the desired value, consumer demand will be something else. And that means frequency has again changed. Again, governor has to take action. Now, why so much importance about the frequency? First of all, I have already mentioned frequency is a dynamic parameter. It will never remain constant. So since it is a dynamic parameter, we have to accept that it has to fluctuate. But the thing is, we cannot afford or allow the frequency to deviate too much. In our country, it is designed for 50 hertz. So as long as frequency is within the tolerable band, typically about the 0.05 hertz plus or minus, that is 49.9, 50.05. Within that range, if the frequency is maintained, everything is fine. But occasionally frequency may deviate, exceed the upper or fall below the lower band. Then in that case, we have to immediately take corrective action. Now, why so much significance about this frequency deviation? Because frequency is the heartbeat of the power system. Just like in a living body, heartbeat is the most important body function. Same way, frequency is the heartbeat of the power system. It is important for the proper functioning of the individual equipments in our homes or offices or industry. And it is also important for the safe and stable operation of the power grid as well. Now, from the equipment point of view, why it is so important is, if you take the total individual loads we cater, more than around 70-75% of these electrical loads are motors. Motors means induction motors, asynchronous motors. If you take your own 600 megawatt thermal unit, and the individual unit will have more than 550 motors, starting from your BFP up to a small dewatering pump of maybe 1 kilowatt or so. So around 80%, 75 to 80% is the induction motors, and these induction motor capabilities or peculiar behavior. Whenever the frequency varies, hertz, that the governor will come into action, and through the governor action, control valve will open, more steam will be admitted, and it will arrest the fall in speed. So the second curve represents the primary governor action, in which that addition stop that to fall in speed, and finally speed or frequency is stabilized. Please note that frequency is constant, speed is constant, but it is not the nominal value, because our original value was 50 hertz. Now with the primary controller, you will never be able to restore the frequency back to the nominal value, and that is why we need the integral action through the secondary control. Your load controller is basically the secondary control, in which a integrator is provided. So as long as there is a steady state deviation, that deviation will be integrated. Integration means it will be added till that deviation becomes zero. So after about 20 to 30 minutes, in certain cases, or maybe 10 minutes in latest unit, finally your frequency will come back to the nominal 50 hertz. This is what happens in our machine through the governor action. So I repeat once again, it has got two major stages, that is the primary control and the secondary control. Under the primary control, there are two stages. One is the inertial control, that is releasing the kinetic energy, and second is the governor action. Because of the fall in speed, governor will come into action, extra steam will be admitted, and it will stop the fall or rise in the speed and stabilize the frequency. But with the action of the primary governor, frequency will not return to the nominal value, and in order to take the frequency back to the nominal value, we have is basically sequence 660 megawatt, 600 megawatt. I hope it is throttle governor, so it may not be applicable in case that is nozzle governor. Whereas in NTPC we have different types of units, supplied by various agencies. So in a single station, we may come across a throttle governor, for example, CPAT in your Chhattisgarh, Bilaspur. There are 500 megawatts throttle governor, whereas 660 megawatt HP turbine is having nozzle governor. And nozzle governor, as far as efficiency is concerned, yes, it is very good. But as far as the controllability is concerned, it is not very efficient. That is why, while rolling the machine, we don't use the nozzle governor. We always roll the turbine through the throttle governor. So in case of a 660 megawatt and TPC CPAT, rolling will be done through the IP turbine. I repeat, through the IP turbine, not through the HP turbine. And later, once the unit is synchronized and a certain minimal load is picked up, then only HP turbine will be getting the steam flow through the HP control valve. That is the difference of the nozzle governor. Now, this is the graphical representation of the operation profile of the throttle valves as well as nozzle valve. The first red line represents the throttle valves. So if you have 4 control valves, all the 4 control valves will be maybe 10% or 20 or 30 or 40 or even 90% open. It will be same for all the 4 valves. Whereas if it is nozzle governor, it will be always in sequence. Initially, 2 valves will open for mechanical stability and thermal equilibrium. So 2 valves diagonally opposite, say 1 and 3. They will open, and once those 2 valve opening reaches around say 20-25%, the third valve will open. Once the third valve opening reaches around say 20-25%, fourth will open. Like that, sequentially valves will open. So this is the nozzle governor. Nozzle governor is slightly more complex in terms of its design, manufacturing, as well as maintenance. And it is not a precise governor also. Rolling, it will not be easy to roll the machine if you have the nozzle governor. Now, if you see the history of the turbine governors, even before steam turbine was invented in the year 1884 by Sir Charles Parson in the UK, England. But before that, steam engines were there. And even before steam turbine, power generation was also there, because power system business started DC generator, because at that time there was no AC generator. And the governor was invented by probably James Watt for his rotary machine, steam engine, because he patented the steam engine in 1785 period, 86 period. James Watt invented his steam engine with rotary motion. Of course, James Watt patented the steam engine in 1769, but rotary motion in around the 1784-85 period. And at that time, he invented the fly bolt governor. And then comes the power sector, starting of the power sector, invention of the steam turbine in 1884. Then comes the World War during the early 20th century. The machine sizes were hardly kilowatt level only. Even megawatt was very few. And they started with the mechanical governor. And after the World War #1, sizes of the generators and the turbines started going up. They exceeded the megawatt, reached the megawatt level, maybe 10 megawatt, 20 megawatt level. And with that increase in the machine size, steam flow, steam pressure, and temperature. With that, ordinary simple mechanical governor was found to be not very efficient and effective. Then comes the hydraulic governor. So during the early 1920s, hydraulic governor has been introduced. What you are seeing is basically the KW turbine Siemens concept. So they sense the speed hydraulically, process it hydraulically, transmit it hydraulically, amplified hydraulically. Why? Because control valves were hydraulically operated. Even today also, the best of steam turbine control valves are hydraulically operated. Of course, in Germany, I understand that they have some electrically operated control turbines because of the high temperature, maybe 600 degrees, 625 degrees Celsius, and current is the Alstom unit. So motors will not withstand that temperature, so they are hydraulic. So accordingly, you need a hydraulic pressure signal for the operation of the control valves. Accordingly, our hydraulic governor has got speed input as hydraulic because speed measurement is done hydraulically, processing is hydraulic, transmission is hydraulic, amplification is hydraulic, and the final operation of the control valve, that is also hydraulic. This continued till around the mid of the 1950s, till after the World War II, and maybe after till about the 1950s. And in 1944-46 period, transistor was invented, and thereafter operational amplifiers become available. Then comes the analog electronics, and with the analog electronics, Siemens has introduced their schematic control system, and with that they have introduced the electro-hydraulic governor with the electro-hydraulic converter. So the advantage of the electro-hydraulic governor is, as compared to hydraulic governor was a single loop controller because it was effectively a speed controller or just a simple controller. But as we know that once the unit is synchronized, speed controller is not a very efficient and effective control as far as load controllability is concerned for supporting the grid. So in that case, it is very difficult to regulate the frequency using the hydraulic governor. So with the introduction of the electro-hydraulic governor, more control features have been incorporated over and above speed controller. They have incorporated load control, pressure control, and whatever is required, that is possible, because imagination is not only the limit. Otherwise, everything is possible. This happened after the 1950s. Now here, all the signal sensing, processing, transmission, amplification, primary amplification, everything has been done electronically. But since the control valves are still hydraulically operated, we needed something called electro-hydraulic converter, where we convert the milliampere or voltage signal of that particular transducer into proportional hydraulic signal. And through that hydraulic power amplifier mechanism, we develop enormously larger power or force for operation of the control valve. So electro-hydraulic governor has got two sections. One is the initial hydraulic section, electronic section, and interfacing between the electronics and the hydraulic EHC, and the final hydraulic section for the operation of the control valves. So in NTPC case, we have all the 500 megawatt with electro-hydraulic governor and the hydraulic governor as a backup. Whereas CPAT onboard 660 megawatt for India's first 660 megawatt CPAT unit number 1. Though that unit on board, hydraulic governor has been completely discarded. Only electro-hydraulic is there. So the sensing, everything is done electronically. And for the operation of the stop and control valve, we have the hydraulic actuators. Now, in case of Siemens, for identifying when you are using low pressure governor, there will be a number of oil signals associated with your unit. So I think in your case, Raigarh, you have got a 250 or 210 megawatt unit. There you have the KW turbine. So everyone will be familiar with that. Nearly about 12 different signals are there. This is the peculiarity about the low pressure governor. Low pressure governor, I mean 8 bar, 32 bar, and 50 bar oil pressure. Because in NTPC, we have 8 bar oil pressure for 210 megawatt, 250 megawatt, 32 bar for 500 megawatt, and 50 bar for 660 megawatt. In these cases, we will have different oil signal, and probably most of you must be familiar with these names. Around 12 names are there. Now, this is the way these signals are interrelated, because the lube oil and the governing, jacking oil, they are basically sub-prime 46. Ordinary lube oil, which we use in our two-wheelers or four-wheelers, and up to 250 megawatt, the same oil is also used for the governing purpose. But 250 megawatt and above, for the governing purpose, ordinary lube oil is not used. It is the control fluid, that is a fire-resistant fluid with a auto ignition temperature more than 700 degrees Celsius. That is the fluid used for the governor. And in case of a typical 500 megawatt, both 8 bar and 12 bar pressure signals are there. Whereas in case of 660 megawatt, only 250 bar signals are there. There is no 8 bar, there is no 32 bar in 660 megawatt. And the latest 660 megawatt and 800 megawatt, there is only one oil pressure, that is 160 bar high pressure governor. In your 600 megawatt Siemens unit, you must be having the 160 bar high pressure governor, because with the increasing pressure, system will become more compact and less complex. So here, those 12 different signals you can visualize from this screen. I'm not going to explain all those things because it will take a lot of time. Now, hydraulic governor is incorporated with or associated with one more additional device in your KW turbine. That is the starting device, starting and load limiting device. This is common in your 210 megawatt and 500 megawatt, but probably there is no physical starting device in your 600 or 660 megawatt. But BHEL must have or Siemens must have given a virtual starting device. It will behave exactly like a starting device, conventional mechanical starting device. It is basically an override over the hydraulic governor. And it is linked with the hydraulic governor. So unless you bring down the starting device to the bottom position, that is 0 position, you cannot reset the master trip device of the turbine, the so-called trip gear. And the trip gear is the source of the most important oil after the lubrication, that is the trip oil. And trip oil is necessary for keeping your steam-related valves such as stop valves, control valves, and NRVs. These valves can be kept open only with the trip oil. So whenever any turbine protection operates, maybe overspeed or low vacuum or thrust bearing or lube oil or boiler tripping or generator tripping to turbine trip, the trip oil will drain, and ultimately draining of the trip oil will close the stop and control valves and RVs, and that's what we call as the turbine trip. So after every turbine trip, we have to re-establish the trip oil, and for that, in your KW turbine, Siemens turbine, you have the starting device, and you have to bring down the starting device to 0. With that, the auxiliary startup oil will build up, and that will enable the trip gear to change the port position. With that, the control oil will develop as the trip oil. And the auxiliary trip oil, in case of your 500 or 250 megawatt, you have auxiliary trip oil as well, which is connected to the individual protective devices. So this is the way the trip gear and the starting device and the hydraulic governor are interconnected. Hydraulic governor consists of a speeder gear. Speeder gear means basically it's a combined effect of a spring and a bellow combinedly acting on a tiltable plate, which in turn regulate the drain port, that is the so-called auxiliary follow-up piston. So by bringing the starting device to the minimum position, that is 0 position, irrespective of the governor, whether your machine was earlier running on hydraulic mode or electro-hydraulic governor, if you bring down the starting device to 0, you will completely defeat the governor or block the governor. That means the oil which is required for opening the control valves, in your case, that is what you call as the secondary oil. That secondary oil will drain completely, and thereby all the control valves and the stop valves will close. That is what turbine trip. So starting device has got a very significant role to play as far as the initial activities are concerned, even during the normal running also concerned. Now, both the hydraulic and because KW turbines are having both the hydraulic and electro-hydraulic, these two are joined and interfaced to a common link, and finally we get the secondary oil pressure. Now, one of the important parameters which is working behind the screen, because that is a very silent parameter, that is the governor droop. That is what we call as the frequency influence. And whenever your machine is connected with parallel with any other machine, if it is a single machine connected with a single dedicated load, droop may not be necessary. But as long as 2 and more machine, because utility level, hundreds or even thousands of units are connected, so droop is necessary, and droop is basically doing 2-3 activities. Now, what exactly is the droop? Droop is basically whenever machine unloads from full load to 0, maybe because of the opening of the generator circuit breaker, electrical output has become 0, and with that steam energy still going into the turbine, machine will accelerate, and finally it will stabilize somewhere. So in this particular graphics, you can see that suppose a machine output has changed from 100% load, say 600 megawatt to 0. With that, there is a rise in speed of say 5%. From 3000 RPM, the speed has gone to 3150 RPM. So in that case, we say that this unit is having 5% droop. Mathematically, droop is defined as the ratio of change in megawatt for a change in speed. So if suppose there is a change in frequency and there is a change in megawatt, so droop capital R is defined as delta F divided by delta P. So that may, for an incremental change in speed or frequency, how much is the corresponding incremental change in the power output of the machine. This is what a mathematical definition of droop. Now, for thermal machines, steam turbine, droop is recommended in the range of 2.5 to 8%. But in our country, as per CERC, droop is for thermal machine, the droop is recommended in the range of 3 to 6%. And NTPC by default, droop for steam turbine is 5%. That means when there is a 5% increase in speed or frequency, machine will completely unload. Now, droop actually having an inverse relationship with the machine response. Means if you reduce the droop, machine will become faster or more responsive. And if you increase the droop, machine will become sluggish in response. For example, if you have two machines with say 4% and 6% droop, and when there is a change in load, machine with the lesser droop will contribute more, and a machine with the larger droop will contribute less. So that way, droop is also responsible for load sharing. And another job of the droop is, or role of the droop is proper load sharing between the units. Suppose say you have 10 units in your power plant. How these 10 units will share their load whenever there is an extra demand for power, frequency falls. So that actually you can correct by tuning the droop. Another important parameter is the deadband. Deadband is basically the any questions or okay. Deadband is basically intentionally set a time delay, because we know that our design speed is 3000 RPM or 50 Hertz. So whenever the frequency deviates, even say speed deviation by even 0.1 RPM, ideally governor should respond, but that is actually unnecessary, because even a minor speed change of say 0.1 RPM, 0.01 RPM, if the governor start responding, your control valve life will be getting affected. So in order to reduce those kind of responses, intentionally manufacturers set a time delay. This is what we call as the deadband. In fact, there are two deadband. One is the natural deadband. Second is the intentional deadband. That is around 0.3 RPM. That means unless the speed variation is 0.3 RPM or more, governor will not respond. And the next one is the transient speed rise. Transient speed rise is whenever suddenly there is a drop in the electrical load, like say generator breaker open, or maybe a transmission line. Suppose from your switchyard station, there are 3 lines going out. Suddenly one line trips, 2 lines are there. So naturally the electrical load on the system has reduced, and that will result into acceleration of the prime mover. And if the speed exceeds the rated value or recommended value, because we know that prime movers typically having a overspeed set value of 110%, 111 or 114%. In NTPC, some units are having 110 and 111%, or 110, 11, 12, or 110, 11 and 114 up to 114% settings are there. So if suppose say because of the mismatch in the supply and the demand goes very high and बोलिए I am not able to, when I am muting, actually, mine is also getting muted. That is the problem. Okay, let it continue. Okay. Now coming to the protection, because turbine, generator, these two are the most critical components of the power system, because boiler, even though behind the turbine there is a boiler, but as far as the power grid is concerned, power grid is not directly seeing the boiler. Power grid is directly seeing the generator, and generator is driven by the turbine. So these two components, that is turbines and the generators, are the most important component from the power sector, power system point of view. And for the protection purpose, these systems are having multiple levels of protection schemes. Normally in NTPC, minimum 2 channels will be there. There may be 3 also, but my experience, as far as my professional experience, I have worked in Faraka, Korba, and Singrauli. There usually only 2 channels were there. Maybe in the latest unit there could be 3, but I'm not very sure about that. I'm not sure about your Jindal also, but probably you may be having minimum 2 channels, so that if channel 1 fails, the second will be effective. That is the way. Now, typically, high capacity steam turbine, whether it be 500, 600, 800, etc., usually 20 to 24, even more number of protections will be there, because these protections have been incorporated not in a single day. These are all historical. If you consider the earliest turbine, maybe some 140 years back, when Charles Parson has introduced the turbine, there were not many protections available. Even till the World War #1, protections in the steam turbines were very, very few. With experience and increasing size of the unit as well as the complete grid size, required for a higher protections and a more number of protections. See, if you see a 250 megawatt machine designed maybe some 20 years back, whereas the 800 megawatt commission today, you will find at least some 5-6 protections are missing in 250 megawatt machine. That was the way. So almost every factor or every dynamic parameter associated with the turbine, YBO, pressure, temperature, flow, level, etc., every parameter is considered, and not only that, the speed. So you have 2 groups of protection. Earlier, up to 660 megawatt, or rather before 1950, only mechanical protections were there. And after 1950, because of the operational amplifiers, electronic circuits have been introduced, and after 1997, digital electronics will become available. So since 1975, electronic controllers with the digital cards, other than operational amplifiers, were also introduced. And since 2000, currently we have everything in numerical control, that is algorithm-based control. So technology has actually progressed phenomenally during the past maybe 70 years after 1950. So historically, these protections have been classified into mechanical as well as hydraulic and electrical. Earlier machines had only electric, hydraulic, subsequently mechanical, and finally we have electrical and mechanical. And today's 660 and 800 megawatt do not have any mechanical protection other than that hand rate from the local. This is the typical protection for 800 megawatt. More than 2 dozen signals are there. Everything is not shown in this slide because of the space crunch. But more than 2 dozen protections are there, and in your Siemens 600 megawatt will be having almost the same kind of machine. But at the best of my knowledge, NTPC JIPT unit, unit number 1, that is a Russian turbine, it is having highest number of protection in NTPC, even a little more than the 800 megawatt. So how does the protection work? The master device for the protection, every turbine will have a master trip device, the so-called trip gear. In BHEL or Siemens terminology, we call it as trip gear, whereas in Russian terminology, they don't call it as a trip gear, they call it by some other name. Now, whatever be the name you give, it is the source of that power oil which is responsible for the operation of the stop and control valve. In our Siemens terminology, we call it as the trip oil. So with the trip oil only, stop valves remain open, control valves remain open, and this device is linked with all the master tripping device. It could be mechanical design, or it could be hydraulic, or it could be only electronic. So in your classical design, like in your 250 megawatt, you have overspeed mechanical, low vacuum mechanical, thrust bearing mechanical, etc. Whereas in the latest case, all this overspeed or low vacuum or axial shift, etc., everything is in electronic form. And if you are having only electrical, then that signal will be routed through a solenoid. That is what we call as the remote trip solenoid. It is basically a binary logic, that is either energized or de-energized, and it will simply cut off the oil supply going to the trip gear. Whenever any protection operates, like suppose a turbine loop oil pressure has collapsed, fire protection has operated, axial shift exceeded. So in that case, the trip gear, remote trip solenoid will operate. Normally, it will be in de-energized condition. At the time of tripping, it will energize and cut off the oil which is going to the trip gear. And when the trip gear oil supply is cut off, it will cut off the trip oil, the red oil. And that tripod is responsible for the stop and control valve and the NRV. So finally, operation of any protection, irrespective of the nature, mechanical, electrical, hydraulic, trip gear will operate. Trip gear operation will drain the trip oil. Draining the trip oil will cut off the oil supply. So this is the way the turbine protection operates. Usually, it is divided into two groups. One is electrical and the other is hydro-mechanical or only hydraulic, certain case. In case of electrical, it is the end product or in end operation is the energization of the remote trip solenoid. Whereas in hydraulic protection, the respective oil in KW turbine, we call it as the auxiliary trip oil. That oil will be drained. So whether the RTS energizes or the auxiliary trip oil drain, ultimately the trip gear operates, and the trip gear operation means trip oil will drain, and draining of the trip oil means stop and control valves will close. This is the typical KW turbine. Whereas in case of 660 megawatt CPAT Russian turbine, it is almost identical. They don't call it as trip oil. They don't call it as auxiliary trip oil. They simply call it as power oil. That's it. But for convenience, it is the same thing. Power oil means basically the oil which is going for the stop and control valve operation. That is the trip oil. And here there is one more aspect. In case of Siemens machine, the same trip oil is routed to stop and control valves and NRVs. Whereas in a Russian turbine, they have a dedicated line for stop valve operation, another dedicated line for the control valve operation. Feature is same, only thing is they have bifurcated the line for maybe convenience. And there are certain additional special devices also provided over and above the turbine protection, because turbine protection is a classical design meant for taking care of normal abnormalities like pressure going high, temperature going high, expansion, vibration, etc. Over and above that, from the system point of view, whenever any sudden reduction in the load occurs, because the normal response of the governor may not be adequate enough to support the power grid under that condition. So there are certain special devices. One such important device is the so-called load shedding relay. And this load shedding relay will come under certain condition because it is not an ordinary protective device. For the operation of this device, typical logic is your machine frequency or the power grid frequency must be more than certain preset value. Earlier days, it was 51 hertz. Subsequently, they have reduced the set values to 49 hertz. In case of a 500 megawatt, there should be a sudden reduction in the electrical output by more than 50%. And after the reduction in the load, what is the remaining one? That should be less than 20%. If all these three conditions are fulfilled, engaged, then the load shedding relay will come into service. And the operation of the load shedding relay, it will remain in service hardly for 1 to 1.2 seconds. That's it. And that time delay, how long the load shedding relay will remain in service, that is not in our hand. It is actually depending on the second signal, that is how much megawatt is reduced within what period. And that will decide how long the load shedding relay will remain in service. And the basic functioning of the purpose of this load shedding relay is to prevent the overspeeding chances of the machine in case of sudden unloading. Similarly, there is one more device that is the so-called sequence trimming device or simply trimming device. Because under certain low load conditions, there is a possibility of your HP turbine is getting starved, because you know that those who are from O&M background must have noticed when your unit is running on even at the full load rated conditions, your HP control valve opening will be much less, whereas IP control valves will be 100% open. So if suppose there is a sudden reduction in electrical output, that will result into further closing of the HP control valve opening. So in that case, there is a possibility of HP turbine getting starved, and that will result into very high temperature build up in the turbine blade chamber area, and your blades may be getting affected. So trimming device is basically a device to prevent that kind of operations. So under that condition, when the trimming device comes into service, it will actually try to push the control valve, HP control valve opening further upward and thereby save it. So with this, I think it is already going to be 1 o'clock. So I have actually included only this one because I was told that it is a short duration program. So if you have any particular specific point over and above whatever I have discussed, we can take up. So otherwise, my discussion is over. Over to the coordinator. Any questions, please?
Yes, sir.
Hello?
Yes.
Yeah. Please.
Participants, if you have any questions, you can raise. The people, those who are participating through online also, you can raise the questions. You can mention in the chat box. Rajan, please circulate the mics. Any questions, please?
So
Any?
can I take it that no more no questions?
Ah,
हेलो
yes, sir. There is a question. Yes.
Yeah, please.
सर जो अभी गवर्निंग सिस्टम में बता रहे थे 500 मेगावाट
तो ऑन कर दीजिए.
आपका वॉइस थोड़ा सा आप ऑनलाइन होगा तो थोड़ा सा माइक को थोड़ा सा पास में रखिए. योर वॉइस इज नॉट वेरी मच ऑडिबल टू मी. ओके, कैरी ऑन.
सर ये जो 500 मेगावाट का जो गवर्निंग में था प्रोटेक्शन सिस्टम में उसमें एक वैक्यूम और थर्स्ट बेरिंग का था जो कि 600 मेगावाट में अवॉइड किया गया है. मतलब उसको ट्रांसमीटर के थ्रू लिखा गया है.
600 मेगावाट में अवॉइड नहीं किया है. इट इज देयर बट इट इज इन इलेक्ट्रॉनिक फॉर्म. See the
हाँ
500 megawatt, everything is in mechanical. These are all historical. See, the technology changes has not taken place in 1 year or 1 month. It has taken place during the past 140 years. So initially, जो भी protection आया है, everything was mechanical. So this thrust-bearing protection was mechanical. Low vacuum protection was mechanical. Later on, they have introduced the electronic transducers. So you have now the pressure transducer for the vacuum. You also have the position transducer for the axial shift. So everything has been, since you have the electronic signal, then you can make it electronic. If you don't have electronic signal, then you have to operate mechanically.
ओके सर.
Hello?
This
Okay,
is
sir.
the evaluation of this governing system as well as the improvement in the reliability of electronic system, which
No,
is
it is not
transformed.
that way. See, it is not reliability. The thing is that that time it was not there. See, my basic is operation. When I joined, I started with a 210 megawatt. Then I have worked with a 500 megawatt, and ultimately I also worked at 660 megawatt. So that time in 210 megawatt KW turbine Siemens machine, we had thrust bearing mechanical. Whereas the latest 500 megawatt, there is no thrust bearing mechanical. And in the 660 megawatt, there is no mechanical protection except only overspeed, that is only in CPAP. Whereas in your Siemens machine, you don't have any mechanical device, because the problem with the mechanical protection is, or for that matter, any mechanical device is, they are sluggish in response. Their reliability is less. They are bulky. And since they are dealing with oil, possibility of oil leakage is always there. So there are many reasons, and you have to time, you have to check the healthiness and reliability of the system. That is very time consuming and risky also. Machines may trip also. Whereas if everything is in electronic form, you can do everything online. You can save the data. You can actually correlate 10 months data today, and you can find out what went wrong or what is happening during the 10 month period. Everything is possible, and it is convenient also.
Yes, sir. Thank you, sir. Any other questions?
Hello.
Yes.
Yeah. Good afternoon, sir. Sir, why RTS is provided with the energized to trip? Why it is not provided de-energized to trip, sir?
Actually, there is no specific logic. The thing is, I don't know what is your background. If you are an electrical guy, probably you must have noticed that when you are disconnecting a transformer, you will be switching only the secondary side. Primary side will be always kept in charge condition. Why it is done so? Because if the secondary is not loaded, what is the point in keeping the primary in charge condition? Because If it is completely disconnected, there is a possibility of moisture getting accumulated, and that may actually affect the quality of the winding. So in order to keep that primary and secondary winding somewhat warm, because when primary is taking about 10% of the full load current, there will be a little bit of heat. Same way, if you keep a solenoid either in off condition continuously, now tripping is a turbine trip will not happen daily 3 times, isn't it? It may be once in a blue moon nowadays, maybe 1 year, 2 years. Now, if you keep that solenoid completely in off condition, then there is a possibility that as and when it is necessary after 1 year continuous operation, it may not operate. So that way, in certain design, they have provided the solenoid in the energized condition. But in certain design, it created a problem because if you continuously keep a solenoid in the energized mode, there is a possibility that the winding temperature may go up and it may affect the quality of the winding. So both of it is dangerous and there are risks. In certain design, in NTPC itself, in certain design, it is normally de-energized. In certain other design, it is normally energized. So there is no specific reason. It is up to you. You can ask the manufacturer or supplier what you want. But whatever manufacturer has given or designed, don't change it because what they are supplying, it is because of their experience and feedback and research. It is not just like that they are changing from energized to de-energized or de-energized to energized. There are many reasons behind that. It is not 1 or 2 or 3 reasons. Okay.
Okay. Okay.
Anything else, please?
I think there is a question in the chat box.
Actually, there is a little problem for me because I cannot directly view that chat box. Can you read out that question, please?
Yes,
Yeah.
shall I read it, sir?
Yeah, please, please.
I think it is from Mr. Hadi Abbas Mirza, and he is asking the question regarding that. I think probably it is a droop setting when it is adjusted and any conditions to be met before setting.
Actually, droop is a very, very dangerous parameter. It is not like that I can change the droop just like that. See, theoretically, you can change the droop just like your fan regulator. How you change the fan speed? You simply change from 4 to 5 or 5 to 3, 3 to 1, isn't it? Droop can also be done like that, can be adjusted like that. But the issue is, what is the fundamental role of the droop? Droop is basically used for proper load sharing between different units. Suppose you take NTPC Vindhyachal, that is the largest power station in our country. There are 13 units, 200 and 500 megawatt. Now, suppose there is an additional requirement of 100 megawatt. Suddenly, there was some tripping somewhere, some unit has tripped. Then there is a shortage of 500 megawatt. So the grid has asked the NTPC Vindhyachal, requesting them to increase 100 megawatt additional. Now, there are 13 units available in Vindhyachal. On what basis you will increase the load on which unit? I mean, what percentage load you will increase in unit 1, unit 2, unit 5, unit 10, unit 13? How you do that? It is a very tricky question. If all the units are identical, suppose all the units are same PHEL made 500 megawatt or 600 megawatt or 200 megawatt, then there is no problem because you divide 100 by 13 or say for convenient 10 units. So divide 100 by 10, 10 megawatt. So you increase 10 megawatt in all the units. Problem is addressed. But that is not the case with our real situation because you have a unit which is 30 years old. You have another unit which is just 1 year old. You have a 200 megawatt. You have a 500 megawatt. You have a 660 megawatt. You have hydraulic governor. You have electro-hydraulic governor. That means all these machines will behave separately. So in order to optimize their load sharing, this group is set, and that group is set at the time of initial commissioning or recommissioning. Now, suppose say, imagine that you have group setting of say 5% in your particular unit, 5%. Now, other nearby, suppose say your other unit or other station is having a group value of say both are having 5% each. No issue now. Now, suddenly somebody understood something more about the droop, he went there and increased the droop value from 5 to 6%. What will happen to that particular unit? If you increase the droop, response of that machine will becomes sluggish. I repeat that I have already made a statement that there is an inverse relationship with the droop and the machine response. So if you increase the droop, that machine load sharing level will come down. And what is the outcome? The other unit with the lesser droop will take more load. Then who will allow that? Suppose say you are from say Jindal, nearby NTPC is there. Now in your case, in Jindal power station, some operation or a C&I engineer went there in the control panel and increased the droop from 5 to 6%. Nobody will understand that. Nobody will notice this. But after some time, suppose say there was some tripping or some abnormality in the grid, suddenly NTPC Korba started facing a problem. Their load when for a particular change in frequency, Korba unit number 5 started behaving abnormally. It is taking too much load. Unlike the previous case, naturally they will start investigating that. And finally they will notice that somewhere somebody has played with or tricked with the droop. So changing droop is not that easy. You can change it. There is no, see, from technical point of view, changing droop is child's play. Nothing is there. You just plug in your laptop, change from 4 to 5 or 5 to 6. That's it. Anybody can do. But the consequences will be very severe. And that is why we normally do not change the droop. Once it is set during the initial commissioning period, it's set. That's it. Unless there is some modification or some additional CRC regulation that CRC is asking you to increase your response from your machine. Under that condition, you have to reduce it. But otherwise, normally we don't do it. And this droop is actually used nowadays in case of renewable energy, but that is a altogether different story. I hope I answered your question. Can you respond, please?
Yes, sir. Yes, sir. I think that is the perfect explanation for this question. I think I have given a very detailed explanation. I think if I am correct, these droop characteristics are designed by these boiler dynamics and turbine dynamics, which is mainly in the scope of manufacturer, isn't it, sir? Until unless it is very essential, it need not be disturbed, I think. Am I correct, sir?
Yeah. Actually, these are all from that prime mover background. See,
yes.
For steam turbines, it is typically the recommended range. Actually, there are so many technical details you have to go for that. But
yes, sir.
Just a comprehensive, I'm just putting it. See, for steam turbine, it is usually recommended in the range of 2.5 to 8%. Probably, if you have an experience with KW turbine, for example, you have KW turbine, I think a 210 or 250 megawatt. In that, you have the hydraulic governor. Do you know what is the droop setting in that hydraulic governor? It is 7%. Whereas in the electro-hydraulic governor, it is 5%. What does it mean? Hydraulic governor, by default, it is not a very fast responding. Now, for steam turbine, the recommended range is 2.5 to 8. Whereas in gas turbine, it is less. Normally, from 2% to even 5% is sufficient. Hydraulic turbine, it is even less. It means basically, depending upon the basic prime mover, your droop level will also vary. See, you can also set 2% droop in your 500 megawatt or 660 megawatt turbine. But that will create problem in long run. That is the issue. For a very short period, you can actually accelerate it. But steam turbine, by default, they have their own difficulties because that dN by dt will be affected. You cannot get a very high dN by dt. Droop reducing means you are increasing the dN by dt, load gradient. Steam turbine, you cannot do that because steam turbine coupled with the generator, its mass is about 180 to 250 ton. It's not a small mass. Yes, it is possible in case of a gas turbine because it is a very light machine. But in steam turbine, it is not that easy.
Okay, thank you very much, sir. Any other questions, please? Any other questions? Any message from chat box? Right. Sir, thank you very much, sir. Your presentation was very excellent and it was well organized. And being in faculty, I was really very much inspired with your presentations. The presentation was detailed about starting from the various functions of the governing system and the role of the governor in frequency control and who explained about the basics of how the protection system is there. And during the time of startup as well as normal operation, how it is executed, who explained with very good visuals. And it was well organized and it was a very nice presentation, sir. Thank you very much for your wonderful presentation, sir.
Thank you. Okay, I'm leaving the meeting.
Yes, sir. Yes, you can please leave. Thank you, sir. However, we will be getting connected with in some other program also, sir. Yes. Now we will have a break for lunch. After the break at 2:15, again you assemble back. You will be having another 5 to 6 number of wonderful presentation with the interesting case study. You are requested to be here by 2 o'clock. Okay, then. Thank you. And lunch is arranged in guest house.
Yeah, lunch for all the participants arranged in the guest house. Sorry, this JIPT hostel.
JIPT hostel, sir.
Yeah, we will go there, and after lunch we'll assemble here at 2 o'clock. Then.
Yeah.
Thank you very much.
The PGDC students, you can leave to hostel and you have your lunch and again come back. Okay. Thank you. Welcome back after this post-lunch session. And we are going to have 3 to 4 more presentations. The first presentation will be presented by JPL Tamnar, and which will be delivered by Mr. Sudeep Gyan, Manager C&I, who is having more than 17 years of experience. And I request Mr. Sudeep Gyan to present the presentation on case studies of turbine governing system.
Hello. Good afternoon. My name is Sudeep Gan. I'm working in 4 into 250 stage 1. And recently, अपना unit 4 में एक problem आया. Last 2 or 3 months से चल रहा है. Suddenly एक problem है, plunger coil fault आ गया और एक deep आया, फिर normal हुआ. तो हम लोग ट्रेंड देखे, उसमें मिला कि वो कमांड जो अपना 100% था, फुल ओपन वाइड ओपन में चल रहा था मशीन, और कमांड में कोई डिमांड में कोई चेंजेस नहीं आया. लेकिन मेरा कॉलिंग ट्रांसमीटर का फीडबैक, 2 फीडबैक 75% तक, एक 75 एक 78, तो एक जो मैक्सिमम था वो मैक्स में 78 था. फिर अप टू 6 और 7 सेकंड में फिर नॉर्मल भी हो जाता है. एक पिकुलियर प्रॉब्लम. तो फर्स्ट हम लोग आया ये 19 मार्च को 78 to 55%, 75% आया. और उसमें और भी देखा हम लोग, एचपी सेकेंडरी वाल प्रेशर जो है 5.15 चल रहा था, 100% ओपन था, तो वो 4.65 तक आया. और आईपी सेकेंडरी वाल कुछ चेंजेस है, और लोड में भी फर्क ज्यादा नहीं, चेंज नहीं आया. तो देन हम लोग नहीं एचपी काउंटर वाल्व में, हाँ उसमें प्रेशर में आया है, प्रेशर में फर्क आया, लेकिन उसमें नहीं आया, लोड में नहीं आया. जी आईपी में नहीं है ना सर, वो तो पहले नहीं आ रहा ना. अच्छा सॉरी. सो हम लोगों ने पहले देखा कि इसका फ्लंजर कॉइल वोल्टेज चेक किया, तो हम लोगों को पहले डाउट आया कि कोई जो मैक्स में था, जो जिसको फॉलो कर रहे थे कंट्रोलर, वो कहीं कुछ प्रॉब्लम किया, उसके चलते कंट्रोल को तो डायरेक्टली फीडबैक आता है थ्रू हार्डवेयर में, तो वो कहीं प्रॉब्लम कर रहा है. तो हम लोग वो ईएसटीसी जो ईएसटीसी 1 था उसमें मैक्सिमम था, तो उसको हम लोग चेक किया, तो सोचा कि ठीक है इसको हम लोग फॉलो में रखते हैं. जो कंट्रोल में था, एक्टिव में था, उसको फॉलो में कर दिया, इसको एक्टिव में कर दिया दूसरे वाले को. लेकिन वी केप्ट इन ऑब्जर्वेशन, आई थिंक 1 आवर हाफ वन, कोई दिक्कत नहीं है. तो फिर हम लोग मशीन को ईएससी मोड में डाल दिया. फिर अचानक फिर आया ये प्रॉब्लम, फिर सेम सिमिलर इंसिडेंट, 6 to 7 सेकंड सस्टेन, देन एक नॉर्मल. तो हम लोग क्या किया, तो हम लोग को लगा कि ये जो डिमांड जा रहा है मिलियन पर आउटपुट, वो हो सकता है कहीं ना कहीं वो ड्रॉप कर रहे होगा. तो उसको हम लोगों ने, वो क्या रिडंडेंस कार्ड से थ्रू जाता है, कभी कभी वो ड्रॉप करता है. ऐसे इंसिडेंट हम लोग 600 में मिला था. तो फिर हम लोग वहाँ पे नॉन रिडंडेंस थ्रू जाता है, तो इसको हम लोगों ने क्या किया, डिमांड को नॉन रिडंडेंट थ्रू दिया, सप्लाई दिया, मतलब मिलियन पर आउटपुट दिया उसमें. फिर ऑब्जर्वेशन रखा, तो वो भी सही चला. फिर सिमिलर और कुछ दिन के बाद फिर प्रॉब्लम आया, तो हम लोगों ने उसको क्या किया, एक आइसोलेटर लगा दिया इन बिटवीन. डायरेक्टली हार्डवेयर तो जाता है डिमांड आउटपुट टू कंट्रोलर, पीआईडी कंट्रोलर इनपुट, तो उसको बीच में हम लोग आइसोलेटर लगा दिया, एमटीएल का आइसोलेटर के थ्रू दिया.
उसमें भी देखा, फिर मैंने 2 चेंजेस किया। एक तो जो पहले एक्टिव था कॉलिंग ट्रांसमीटर, उसको नॉन एक्टिव कर दिया, फॉलो में कर दिया। तीसरा किया, उसको नॉन रीडर कार्ड के थ्रू दिया। और चौथा किया, उसमें बीच में आइसोलेटर लगा दिया। मे बी समर लोडिंग। तो चलने के बाद हम लोग उसमें भी कुछ दिन चलता है, फिर सडनली फिर से प्रॉब्लम आता है। तो हम लोग ग्राउंड वगैरह देखा, सब ठीक ठाक मिल रहा है। मतलब कहीं ना कहीं कुछ, इवन जो ट्रिपल प्रेशर जाता है, वो जो कोयल में, इसमें गवर्निंग सिस्टम में, उसमें भी सब प्रेशर वगैरह से कोई वेरी भी नहीं हो रहा है ज्यादा। तो हम लोग क्या क्या फिर पीआईडी कंट्रोलर, बेसिस ऑफ डाउट, हम लोग क्या इन बिटवीन हम लोग ईएसटीसी फीडबैक और जो डिमांड जाता है पीआईडी कंट्रोलर को, हम लोग तीनों मल्टी में लाकर कंटिन्यू वेरी देखते हैं, कंटिन्यू मॉनिटरिंग करता है पैनल में कि कौन ड्रॉप कर रहा है। एक्चुअल में डिमांड तो चेंज नहीं हुआ, डीसीएस हम लोग तो जब जब हम लोग एक्सरसाइज करता है तो मशीन को हाइड्रोलिक में डाल देता है, उसमें कंटिन्यू 100% में फोर्स कर देता है, तो डिमांड में कोई चेंज नहीं है। तो हम लोग उसे मल्टी में ला करके रखा है कि जो कोई ड्रॉप तो नहीं कर रहा है। ये भी हम लोग उसके बाद में हम लोग ये सब माने नॉन रिडेंस कार्ड में दिया, फिर बीच में आइसोटर लगाया। वो कंटिन्यू हम लोग फीडबैक भी मॉनिटर करता है, और वो फिजिकली पैनल के सामने हम लोग 3 मल्टी लगा कर मॉनिटर करता है। फीडबैक में खाली पता चलता है डिप किया, लेकिन डिमांड में कोई डिफ नहीं है कुछ। फिर वो 6-7 सेकंड बाद फिर अब नॉर्मल भी हो जाता है। तो इस तरह का कई बार प्रॉब्लम आया, तो हम लोगों ने उसमें 5th स्टेज में हम लोग कार्ड चेंज किए, पीआईडी कंट्रोलर चेंज किए, इवन उसका जो एनालॉग आउटपुट कार्ड भी चेंज किया वाला लास्ट में, और एवीएल कार्ड जो फाइनल एम्पलीफायर कार्ड जो है उसको भी चेंज किए। वो 1-2 महीना, आई थिंक 2 महीने चला। फिर एक दिन 18 एक मिनट, अगस्त का 6 तारीख को फिर प्रॉब्लम आया उसमें, ESTC2 फ्लक्चुएट किया। ऐसे जस्ट अर्ली मॉर्निंग में प्रॉब्लम आया 6:41 के आसपास में। तो हम लोगों ने क्या कहा, उसको डेविएशन आया। इसमें क्या है, इस बार वो प्रेशर में ड्रॉप नहीं हुआ, लेकिन कॉलिंग ट्रांसमीटर का फीडबैक में फ्लक्चुएट रहा है। दोनों के बीच में 10% के ज्यादा डेविएशन हो गया, तो प्लंजर कॉल ऑफ हो गया, ESTC फॉल्ट आ गया। तो ये इशू है। इस बार तो लगा कि हाँ ये ठीक है, अभी सेकेंडरी वाल में कोई ड्रॉप नहीं हुआ। तो हम लोग क्या किया, उसको कॉलिंग ट्रांसमीटर को देखा, खोला, उसको चेंज किया। ऐसे 9-11-12 बजे तक चेंज कर दिया। इस बार नहीं चेंज हुआ, खाली कॉलिंग ट्रांसमीटर फीडबैक 2 जो है, जो मतलब वो डेविएशन आया ESC1 से 10% में, वो 99 पॉइंट समथिंग था, 89 से नीचे आ गया। तो 10% आ गया, वो प्लंजर कॉल ऑफ होकर फॉल्ट आके चला गया। तो हम लोग उसको प्लंजर कॉलिंग ट्रांसमीटर लगभग 11 बजे के आसपास चेंज कर दिए। लोड में कुछ नहीं हुआ, उसमें लोड नहीं था। लेकिन एक पिकुलर हम लोग क्या का, इससे पहले भी कभी को होता कि एक ट्रांसमीटर दूसरा ट्रांसमीटर जो लेटर था, एक डेविएशन का हम लोग अलार्म डाले थे, ये लेस देन ग्रेटर देन 3% का डेविएशन है, तो एक ऑपरेटर को एलिवेशन में अलार्म दिए थे, ताकि लोगों को पता चला कुछ प्रॉब्लम तो नहीं है। नॉर्मली क्या हम लोग 2%, 1.5% मैक्स, और दोनों जो बीच में डिफरेंस रखता है। तो उससे अगर ज्यादा किसी कारण से अगर सडन कोई लोड चेंज हो रहा है, उसमें अगर वो फॉलो नहीं कर, वो तो साथ साथ चेंज होता है, तो कहीं अगर डिले हुआ, कुछ प्रॉब्लम है, तो अलर्ट करने के लिए हम लोग उसमें एक डेविएशन, इसी से वो लोग पता चलता है ये कुछ प्रॉब्लम आया। तो ये जो 10% आया था लास्ट 6 तारीख को, 6 अगस्त को, तो उसमें एक खाली ESTC2 का ही आया था प्रॉब्लम। तो उसको हम लोग चेंज कर दिया, लगा कि हाँ कुछ प्रॉब्लम है। तो खोल के तो कोई टाइटनेस वगैरह सब सही जाए, प्लंजर खोल के उसमें टीवी में जब बॉक्स खोलेंगे तो कोई ऐसा कोई कुछ नहीं था। तो ठीक है, वो मे भी प्रॉब्लम कर सकता है। इससे पहले भी एक 3 में प्रॉब्लम हुआ था ESTC का 2 का, तो हम लोग उसको चेंज किए थे, तो शॉर्ट आउट हो गया था। तो ऐसा लगा कि वो चेंज किया 11 बजे आसपास, हाँ 11 बजे आसपास चेंज करके, फिर रात को, उसी रात को 7 तारीख को रात को प्रॉब्लम आया। फिर अब दोनों हंटिंग किया, तो उसमें भी आके फिर ऐसे केबल वगैरह भी, हाँ इसमें हम लोग केबल प्लंजर कॉल टू मॉड्यूल, एम्पलीफायर मॉड्यूल टू प्लंजर कॉल, जो केबल एग्जिस्टिंग केबल है, उसको दूसरा एक केबल डाल के उसका भी हम चेंज कर दिए थे, ये प्लंजर कॉल का, उसमें भी कोई फर्क नहीं पड़ा। तो ये इंसिडेंट आया। इसमें भी एक ये कॉलिंग ट्रांसफर दूसरा चेंज किया गया दोनों में, अब अभी दोनों में नया है। तो चला ये 7 तारीख का इंसिडेंट है, 7 अगस्त। और फाइनल 15 अगस्त को ये प्रॉब्लम फिर से आया। तो हम लोग तो सोचे कि और क्या कर सकते हैं, तो लास्ट ऑप्शन बचा था प्लंजर कॉल में काम करेंगे। यहाँ पे सब लगा कर देख रहा है, वही सेम प्रोसीजर हम लोग फॉलो कर रहा है, सब देख रहा है, तो कहीं पे कुछ क्लू नहीं मिल रहा है। तो फाइनली हम लोग सोचे कि एक बार प्लंजर कॉल ओपन करता है, देखता है उसमें काम करता है एक बार। तो टेक्नीशियन को भेजा गया वहीं पे, तो उसको बोला तुम जाकर उसको ढक्कन खोलो। तो हम लोग तो मल्टीमीटर लगा के रखा है, ये स्थिति दोनों का फीडबैक में वो फ्लक्चुएट कर रहा है, कंटिन्यू फ्लक्चुएट कर रहा है। तो सडनली देखा कि एकदम रीडिंग स्टेबल हो गया, एकदम स्टेबल। तो फोन लगा, तुमने क्या किया, ओपन किया ढक्कन? तो बोला कि हाँ सर, जस्ट अभी मैंने ओपन कर दिया हूँ। तो हम लोग को फिर वहां पे 10-15 मिनट ऑब्जर्व किया, ओपन किया हुआ ढक्कन और ऑब्जर्व किया, एकदम एकदम सडनली एकदम चेंज हो गया, एकदम एकदम स्टेबल, कोई प्रॉब्लम नहीं है, जो होना चाहिए नॉर्मल। तो फिर हम लोग गए वहाँ पे, तो ऊपर में एक तो वेंट रहता है, वेंट पाइप ट्यूब रहता है वेंटिंग के लिए। तो डाउट लगा वेंटिंग ट्यूब कहीं चोक तो नहीं होगा कुछ। तो ऐसे फूं मार कर देखा कि कुछ एयर तो बाहर नहीं आ रहा है। तो फिर हम लोग एयर फार्जिंग किया, मैंने लैब में जाके उस प्लेट को उठा के जब मारा तो एकदम चोक था, सडनली पूरा एकदम ब्लैक कलर कुछ दीवार में जाके ठीक है, पूरा लाइन चौक था। तो उसके बाद हम लोग उसको लगाया फिर से दोबारा, और सारे जितना मॉड्यूल्स हम लोग चेंज किए थे सब बैक टू जो ओरिजिनल जो बीएचएल का जो एसएफबी था, मतलब अकॉर्डिंगली उसका हार्डवेयर सब कुछ सब नॉर्मल कर दिया, रिडंडेंस कार्ड कर दिया, वो जो कार्ड चेंज किए थे बीएल कार्ड पीआईडी कार्ड सब चेंज कर दिए, जो था उसको फिर दोबारा लाके उसको लगा दिया। आप 15 अगस्त को अभी भी कोई प्रॉब्लम नहीं आया उसमें। तो ये लगा कि हम लोग मतलब रीजन तो, और मे बी आप लोग थोड़ा भी सजेस्ट करिए जो इस समय काम कर रहा है, और क्या रीजन हो सकता है। और हम लोग जो सोचे है कि ये जो वेपर जो प्रेशराइज कर रहा होगा, तो उसमें कुछ प्लंजर कॉल में कुछ प्रेशराइज कर रहा है या कुछ वो मैन्युफैक्चरिंग कर रहा है। तो इसलिए हम लोग लगा कि जब भी कोई अपॉर्चुनिटी शटडाउन मिले, कुछ मिले, शॉर्ट शटडाउन बीटीएल हो गया, तो जो वेंटिंग है वो थोड़ा सा साफ करना चाहिए। क्योंकि और भी यूनिट में, यूनिट 2 में हम लोग ऑब्जर्व किया है, यूनिट 3 में भी किया है, उसमें मॉइस्चर मिला हम लोग को टीबी के ऊपर में, जितना पे प्लंजर कॉल और ईएसटी फीडबैक का जो टीबी है उसमें अच्छा खासा मॉइस्चर मिलता है। तो हम लोग उसको
आप लोग आपका पैनल की बात कर रहे हैं?
नहीं, प्लंजर कॉल के असेंबली जहाँ जब है वहां पे गवर्नमेंट रैक में, यस टीबी गवर्नमेंट रैक में जहाँ प्लंजर कॉल है जो जेबी है, हाँ
ब्लॉक में ऊपर जो कनेक्शन रहता है वो वाला,
जिसमें
या।
कॉलिंग ट्रांसमीटर का फीडबैक है, प्लंजर कॉल का कनेक्शन है, वो एक टीबी है। हाँ वो टीबी, हाँ जो फील्ड में गवर्नमेंट रैक में जो जहाँ प्लंजर कॉल है वो जो जेबी है, तो उसमें मॉइस्चर, हाँ जी फोटो है मेरे पास, इसमें
फोटोज कुछ
इसको बैक करो ये, हाँ ये आप देखेंगे ना, सॉरी तो जल्दी फाइल, तो ये 10 रखो इसको 10, हाँ ये देखिए, अब देखिए सेट पॉइंट,
No, he is asking photos of
हाँ वो समझ गया, सो इस पर नहीं है, हम
ठीक,
10 देखा ना,
ठीक।
वो मेरे पास फोटो आपको दिखा
ट्रेंड्स
देंगे,
का
ठीक,
कोई
हाँ तो ये
trending
चीजें
material।
वो आप फोटो हमको दिखा देंगे, ये देखिए ऐसे इसमें नहीं वो एक्चुअल जब शुरू में तो वो सेकंड वॉल प्रेशर ड्रॉप हो रहे थे।
Actually, it was not the feedback problem. That was there may be the two reasons. One is due to pressurization, another
Yes,
is the due to condensation. of the-
Condensation. Yes,
Yeah,
sir.
that may be the reason.
He
But
was-
again, we have to find out what is the exact reason.
exact reason,
Whether
yes,
it is the condensation or pressurization.
कंडेंसर तो मिलता है वहां पे
In
इसमें,
my sense, that may be the due to condensation only. Yeah, due to condensation that TB contact, this wiring contact may not be perfect, and in that way, that's why that signal may be disturbing.
लास्ट सेकंड लास्ट या थर्ड उसमें हम लोग चेक किए थे, तो उसमें कोई मॉइस्चर या कंडेंसेटर कुछ नहीं था, वो तो हमने सोच कर चेक किया, लेकिन
visible in that
हाँ,
case. But definitely there will be there are more probability of this condensation only.
Yes, sir.
Pressurization will not be the issue.
लेकिन वो एक्चुअल शुरू में तो पकड़ में
But
आता था.
actually, this is the observation of most of the sites. That's why that venting is given.
Yes, sir. So last
Most
अभी
of the
देर
time, where the
Possible due to the hunting of the secondary oil pressure. It is reverse.
no. It is not due to the hunting of the secondary pressure. Secondary pressure source is the ESTC, na?
Correct.
Or this pressure generation or all these things. The source is the ESTC.
Yes.
And in that case, that is the only electrical source is there for this hunting. It is clear. Only there may be the two reasons. One is the pressurization due to the there is no hunting at all, and due to rising the temperature. Another is the condensation.
Condensation.
yes, sir.
And there is
So
more
this is a
possibility
common
of
problem
condensation.
everywhere. Is a hunting for few instance for sometimes.
But normally, where the plunger coil is installed in most of the BHL make plants, by experience,
Yeah.
we give the venting.
Okay, sir.
Yeah.
Okay.
Most of the sites it is.
Okay.
नॉर्मली हम लोग इस तरह का प्रॉब्लम फर्स्ट टाइम फेस किया, जो ये भी एक रीजन हो सकता है.
No, it is not the
मतलब-
first time. Actually, you know, known of us was in the commissioning.
Yes, sir.
That's why that at the commissioning stage that venting is given. In my earlier plant also, we have given the venting there. It is the feedback from the BHL sites.
मतलब ये माने एवोल्यूशन फेज में आया, जो इसको वेंटिंग होना कहीं प्रॉब्लम फेस किया है लोग, तो पहले से इसलिए तो ये चीजें आया है. Yes, sir.
Modification was
Venting.
suggested given. There must be the, some background, no?
Yes, sir. ठीक है, और कोई रीजन जैसे
नहीं,
डिस्कशन में है और कुछ है जो
there may
हंटिंग?
be only two reasons. I don't know which may be predominant.
तो कभी लूजनेस के लिए भी आ सकता है सर.
Yeah, it was not due to the looseness. Looseness का कोई reason नहीं.
नहीं,
Yeah.
yeah, they have find some other reason, but otherwise maybe the possible cause for looseness or
This is the standard modification given by the BHEL
okay.
in the all the plants where this plunger coil system is given.
Okay.
That's why it is due to that one.
लेकिन
Not
इस तरह
for
का
the looseness.
चोक मिलेगा, मतलब लाइन माने छोटा सा ट्यूब है, वो भी ऐसे ही 1/2 इंच का ट्यूब है और 12 इंच का ट्यूब है. तो वो ऐसे चोक हो जाएगा, तो कोई सोचा नहीं था इसके वजह से ये इफेक्ट आ सकता है. जबकि टीवी टाइटनेस या मॉइस्चर हम लोग वो तो पहले टेक केयर किया, तो लेकिन उसमें कुछ एक्शन नहीं हुआ. तो पर फाइनली जब मिला, तो अभी तक तो प्रॉब्लम नहीं आया. हम लोग सारे चीजें जो है एज पर BHL उन्होंने रीइंस्टॉल कर दिया, सब वही कार लगा दिया. अब देखते हैं अभी तक.
Yeah, go ahead and for next case.
सर ये सिंगल केस. यस सर.
That is only one case study.
यस सर. थैंक यू.
Participants, do you have any questions regarding this case study? Anyone from online who has joined in online? उनका कनेक्शन है ना सर. अच्छा, मीटिंग चार्ट. अच्छा, there is a feedback message from Hadi Abbas Mirza, and in the chart he has mentioned the following points. This may be also checked during the shutdown period, that is cleaning of return oil filter in the return line and check the vapor line in the return line.
There is a provision.
Yeah, thank you, Adi, for your feedbacks and about the alternate reasons of it.
Right. The next session will be presented by DB Power Limited, Raigarh, and it will be presented by Mr. Gadi Abbas, AGM Turbine Maintenance. And Gadi Abbas is having an experience of more than 17 years in turbine maintenance. And I request Mr. Gadi Abbas to present the presentation.
So I am audible.
Yeah, Abbas, you are audible now. You can continue, please.
And
Yes, sir.
yeah.
Good afternoon, all. I'm from DB Power. My name is Hadi Abbas Mirza. We'll see just a minute. Types of governing system. Mechanical governing system basically takes the input from speed of the turbine, and then mechanical as a speed transit. If you see the BHL made turbines, MOP, there is it will give a primary oil pressure. Basically, that pressure will be act as a speed sensor. It is a indirect type of speed sensor, basically. And this speed primary oil pressure, it will take as a speed sensor and then generate the hydraulic signal, and operation of control valves will be done. We'll see how it will works in hydraulic type of governor. Okay, that slide I have deleted, I think so. Okay, no issue. I will show you in forward slides. Electro-hydraulic converter, in this, there are two sensors will be there. One is speed sensor and electronic speed will be a signal to electronic hydraulic converter, and then it converts into electronic signal and proportionate hydraulic signal for the operation of the valve. This basically takes the signal from speed sensor transducers, and then it converts into hydraulic pressure, and this in turn govern the control oil, control valves, and speed, load, everything will be controlled like this. There the types of governing system depend on the steam admission. Basically, valves design is throttle governing is there. Our 600 megawatt or 250 megawatt, this basically works on this throttle governing. In this governing mechanism, mass flow rate controlled by throttle valves in desired pressure. Controlling parameters is speed, load, and pressure. Basically, it takes speed as an input, load, and pressure, and gives the control valve opening as a output. Our turbine is a reaction turbine working on throttle governing principle, in this governing system separate hydraulic and working system. In this both electro-hydraulic and hydraulic both are working. We have seen this governing mechanism. Nozzle governing. Nozzle governing is basically used for low part load conditions. In this method, flow is regulated by opening, closing some set of nozzles of the turbine. Basically, in TDBFP, you can see this type of nozzle governing, in which 5 to 6 valves are there in governing system. Depending on load, some of the nozzles put in service and some put in out of service. Basically, when the load is around 350 megawatt load, TDBFP valves will be opening around 3 to 4 valves will be in operation, and remaining valves will be in closed condition. We'll see in next slide what is the nozzle governing. Nozzle governing part load efficiency is higher as compared to throttle governing. This is nozzle governing. It is shown here that there are 3 sets of nozzle valves here. Basically, whereas 5 to 6 valves are there in our TDBFP. Have taken this just to show you what will happen in this nozzle governing. Steam inlet here. Once at initial stage, this nozzle will be in operation in partial load. First, this valve will be open fully, and then the second valve will get operated, and then third valve will be operated. By this, there will be a play in this. Basically, there will be a play in these valves. First valve will be opened fully, and then only the second. Basically, this word will be said as lift of the valves. Lift will be designed such a way that first this valve will be opened, and then only the second valve will start opening in this. These are some different oils covered in governing system. Most of you know regarding this governing system oils. What are the oils used in this governing system? One is control oil, trip oil, auxiliary trip oil, startup oil, auxiliary startup oil. Don't go for this. Some graphical mistake is here. This is basically white and red will be here, and here auxiliary startup there will be a orange and white, and in auxiliary secondary oil it will be white and blue. This blue. The types of oils are we have studied: control oil, trip oil, auxiliary trip, startup oil, auxiliary startup, auxiliary secondary oil, primary oil, test oil, and trains. We'll see what are the purpose of this control oil. Control oil is to establish trip oil, auxiliary trip oil. Basically, all the oils generated are from control oil only. In medium pressure governor, that is 600 megawatt, we have 8 bar and 32 bar basically. In that control oil is around 32 bar and 8 bar is for governing system. Servo valves, it operates at around 32 kg, and for governing it is around 8 kg bar. 8 bar, sorry. Trip oil is to reset, open, close, stop valves. Auxiliary trip oil is to hydraulic trip devices like overspeed trip device. We don't have in 600 megawatt. We don't have this vacuum trip device. But 250 megawatt BHL make, we have it auxiliary vacuum trip device also. This auxiliary trip oil is tripped in overspeed trip release device. Startup oil is to reset the startup valves, test valves, and reset. Basically, stop valve will be reset here. Auxiliary startup Main trip wall is reset here, and hydraulic trip devices like overspeed trip device, trip release device. Secondary oil is input signal for servo motor of control valve. So auxiliary secondary oil is input for hydraulic hydraulic converter. Primary oil is a feedback signal. It is a feedback from turbine, basically. It acts as a feedback signal for hydraulic governor. Test oil, we just inject a overspeed trip device. For that, test oil is generated. For 250, it is control lube oil only, but in 600 also it is lube oil only. Whereas control oil is control fluid. Drains are denoted as brown color here. That is what I have already shared you. We'll see. Control oil is AOP, MOP or control fluid discharge header. That is called control oil. Trip oil, these are two circuits are established through main trip valve under reset condition. Once the control oil passes from main trip valve, it becomes main trip oil, and auxiliary trip oil will be initiated or generated from main trip valve. Auxiliary trip oil and auxiliary startup oil are the two circuits are established to its peak pressure through starting device. When the control oil comes to starting device, these two oils are generated, startup and auxiliary startup, which is denoted by orange color and white and orange. How it will be generated, we will see in next slide. From 0 position to 100 position, it will generate addition. First, it will generate auxiliary startup, and then startup will be generated. For resetting the trip devices, it is basically used. Auxiliary secondary oil is nothing but a hydraulic governor output and input to hydraulic converter. Secondary oil is output of hydraulic electro-hydraulic converter. This goes to control oil and governs the control valve. Test oil is the circuit established to overspeed trip device when turbine is running at rated speed. These are some devices which are in governing rack and protection rack. These are the main devices I have covered. Remote trip solenoid. There are two remote solenoids in this governing system. Basically, they are in series. These solenoids are gets energized and control oil gets drained through the walls and trips the MTV. Basically, when the unit any mishap happens, any tripping is to be initiated. First, this RTS will energize and trip the port connected to control oil from trip oil. It will just changes the port from control oil to drain. This is the function of RTS. Basically, it opens the port from control oil to trip. It changes the port of valve from control oil to trip oil to control oil to drain. When the unit is trip, it means port from RTS is changed from control oil to drain. Basically, this happens in RTS. Main trip valve. This is a mechanical device. In this, there are two pilots in this auxiliary pilot and main pilot. Basically, in this main trip valve, control oil converts into trip oil and auxiliary trip oil. That is what written here. And then trip oil will convert into secondary oil, HP secondary and IP secondary. Starting device, as a name suggests, the device is used to reset the opening stop valves. Basically, stop wall, when both we call stop wall as a cup and saucer type of servo motor. For operating the servo motor, first the spring has to be compressed in cup and saucer type of servo motor. For that, the starting device will act as a fluid for resetting the stop walls. Speeder gauge is the combination of starting device and hydraulic governor. Basically, for rolling purpose and resetting the turbine, this device is used. This can be operated from local or motorized. It can be operated. Hydraulic and electro-hydraulic converters and its amplifier converts hydraulic and electrical signals to hydraulic signals. Basically, when the tripoil generates, after tripoil generates, this comes to electro-hydraulic and hydraulic converter. These are two devices separately with follow piston in each devices. The function of this hydraulic converter is to convert tripoil into required secondary oil pressure for the control valve opening. Hydraulic trip devices. These devices are basically hold the auxiliary tripoil pressure until and unless any trip commands come to it, or overspeed trip is if mechanically if RPM increases, then also this device will operate and trips the unit. For resetting this auxiliary hydraulic trip devices, this startup oil is used for resetting these hydraulic trip devices. If anyone is having any doubt, you can please stop and ask me. No? This is a simple block diagram I have indicated here. Control oil around 8 kg bar. It will comes to main trip wall and then stop walls. And this trip wall, it is a basic simple diagram I have shown here for basic understanding for newcomers. Control oil comes and main trip wall and then four stop walls, and this trip oil is coming to hydraulic and electro-hydraulic devices, and then it goes to as a secondary oil, it goes to four control valves, whereas 8 bar coming to starting device for resetting these valves, and then it becomes auxiliary startup and startup fluid. Whereas this control fluid 32 bar, the servo motor will work on this 32 kg sun control fluid pressure. Control fluid pump, when we start the control fluid pump, pressure buildups in discharge header, and then it directly goes to trip oil pressure and then to filtered control valves. Then starting device, first it will go to three parts: one main trip valve, starting device, and then control valves. This is a filtered oil. There is a filter in between this control valve and discharge header. Once we operate this starting device, once the RTS is off, that is de-energized to open, de-energized to close. De-energized, when it de-energizes, it will generate the trip oil and gives supply to electro-hydraulic converter and test valves. When you operate the starting device, the secondary oil will be
Startup oil.
Startup oil. Startup oil is generated and reset the test valve. And then first oil goes from bottom of the above piston of the servo motor, and then this spring will be compressed against this cup will be compressed against this spring and come to sit around here. This is called cup and this is called saucer. For a layman, you can understand like this. This is called a cup and this is a saucer. When the trip oil, for resetting the stop valve, when the trip oil comes above piston, then this spring will be compressed first and become a complete single assembly in servo motor. Then when the reset has been completed, then this auxiliary startup oil will be drained, and then the pressure from below piston, the trip oil pressure will go from the below piston and it will completely open the stop valve. This will also open the stop valve. We will see what is the starting device. A basic function of starting device is to reset the hand trip and hydraulic trip devices. Hand trip valve is main trip valve here. Hydraulic trip devices are over-speed trip release devices, and vacuum trip device in 250 megawatt or any other governor system. Resetting and opening stop valves. Here you can see here, starting device will reset the stop test valve and in turn reset the servo motor of the stop valve. Releasing the control valve for operation. Here hydraulic trip devices, it will give the trip oil pressure around 9 kg, and all the 9 kg pressure will be reduced and drained until and unless the secondary oil pressure command will go from 9 kg, it will become to 3 kg and stay around 2.8 kg until and unless the secondary oil pressure command is forwarded or increased. This is how starting device works. When you bring 100 to 0 position, startup control oil comes under in between the ports, and then the auxiliary startup will generate from here, and it will goes to main trip valve and hydraulic trip device, that is overspeed trip release device. To reset the valve, test valve and stop valve, it will go from bottom of the starting device. I'm playing once again for proper understanding. This position is from 100 to 0. When you operate reset the starting device from 100 to 0, the auxiliary startup will generate it, and around 5.5 kg it will generate and goes to MTV, main trip valve, and hydraulic trip devices, that is overspeed trip release device. And startup oil will go to reset test valves and in turn reset stop valves. Once this completely zero up to 0 position, it will reset the valves and trip devices. After 0 to when you go from 0 to 100, it will operate the stop valves and open the stop valves. Around 30 to 45% of starting device opening, the stop valves will be operated. Completely opening of the valves will be done. This is what speeder gear function is shown here. When the even initial condition, when you reset from 100 to 0 position, initially there will be no primary oil pressure here. Sir, I am completing in 5 to 10 minutes.
Sir, your voice is not audible. Sir, we are not able to hear you.
Acha, okay, sir. Someone is muted, I think. Okay.
It's okay, sir. Please continue.
Okay. Sir, this is how the speeder gear works. I have already said just now. Regarding main tripole, control oil comes here, and when you it will generates tripole, and auxiliary tripole is also generated. This is main tripole assembly. Control oil pressure comes here. When the auxiliary startup oil generates from starting device, this piston will go up, and this port will be opening for trip oil and auxiliary trip oil. This is what happens in main trip oil. Now, after main trip oil, the auxiliary trip oil will goes to overspeed trip device, and another is drain ports. This is regarding hydraulic governor. When you, there's some graphic issue, I think so. Chalo. Basically, that is what I have said earlier. The starting device, it will acts as a fulcrum here, and it works against the spring, and then it in turn opens the port sleeve here in follow piston. Basically, what happens here is trip oil pressure will be draining continuously here until and unless the port is closed here. This is sleeve of the follow piston, which closes the draining of the trip oil. Basically, 9 kg pressure will be converted to 5 kg in valve wide open condition. we required, as per requirement, this sleeve will be open and closed by this primary oil pressure in running of the unit. I was told to complete as early as possible, so I am moving forward. That is what showing in this device. Actually, startup oil, basically this startup oil is required for to reset the stop walls and hydraulic trip devices. Normal operation, startup oil are in open condition and trip oil pressure acting from the bottom of the actuator. Turbine tripping will drain the trip oil and will result closing of the stop walls. Closing operation of the stop wall is assisted by pre-compressed spring kept above the stop wall. The release of the spring force quick close stop wall. Therefore, before going for opening the stop wall again, after a turbine trip, this spring is to be compressed. The action needs to start up. Basically, it is a reset of the startup. Startup oil is used for resetting the stop walls and hydraulic trip devices. I have already explained this regarding RTS. These are the parts of servo motor of stop wall. This is the piston disc and spring disc. This is the piston. This is the spring cylinder and trip oil pressure above piston, and this is called below piston. Initial condition, servo motor will be like this without oil. After the trip oil reset condition, trip oil will be coming from this here, and this spring will be compressed like here, like this. And after the reset, this oil will be drained, and again trip oil from below piston will be entered from here, and the servo motor will be opened like this. This is how hydraulic converter and hydraulic converter is operated. Here it is showing three follow pistons. So basically 600 megawatt, it is 2 by 2, 2:2. In 600 they are 3 by 3. Control oil will come here, and auxiliary secondary oil from speeder gear will be a sensing device, sensing oil, and then it will amplifier will be operated with this sleeve, and then the this complete sleeve will be operated up and down. With this, the draining of the trip oil will be done, and the required HP secondary oil will be generated as per requirement. This is the primary oil pressure with respect to turbine speed. The speed increases up to 3000 RPM. Pressure will be around 2.5 kg. Just that's okay. A primary oil function, basically it acts as a sensing fluid for RPM. In hydraulic governor, we have studied the pressure of the discharge pressure of the fluid is considered as a sensing media here. The decrease in this primary oil pressure will increase the pressure of the spring and in turn increases the secondary oil pressure, which opens the valve and increases the speed. That is was the function of the primary oil fluid. This is RTS. RTS I have already said, skipping this. Emergency trip valve. Basically, main trip valve it converts secondary oil into auxiliary trip oil and trip oil. In local also, you can trip the main trip valve by tripping this lever. You can trip the turbine. Basically, what happens while we trip this main trip valve? Oil from auxiliary trip oil will be drained from here. This port will be connected to drain, and actually when it is in reset condition, auxiliary trip oil pressure will be kept as hold here. मतलब वो बांध के रखता है auxiliary trip oil pressure को. जब तक ये है जिंदा है तब तक यूनिट का ऑक्सिलरी ट्रिप ऑयल है तो ट्रिप ऑयल है, ट्रिप ऑयल है तो यूनिट बचा है. Electrohydraulic converter is to position the control valve according to input signal for generating required speed and load. The main components of ESTC and hydraulic amplifier are permanent magnet plunger coil and control sleeve, a rotating pellet, and two coolant transmitters. These are the main parts of ESTC. Output voltage signal of the governor control circuit changes the position of the plunger coil and attach the control sleeve. This in turn changes the draining rate through the ports of the control sleeve, pilot valve, and thus change the position of the pilot valve. Changes in pilot valve position connect the control oil to the power piston either from top or from the bottom side. That is what I have already said in previous slide. Piston movement regulates the draining rate of through follow piston. There are 6 follow pistons. Basically, in 600, there are 4 follow pistons, 2 in each IP and HP. Hydraulic governor remains in service and electrohydraulic remains in maximum position. Draining rate through ESG follow piston will be minimum. If ESG in service, ESG remains in maximum position. Basically, electrohydraulic converter will be in service most of the in almost every time until and unless it is any malfunction in that or any Collins feedback error will come. Then only it will go to maximum position and stay there if any error is come, and automatically hydraulic governor will come into picture. Control valve operation we will see directly here. Okay. Secondary oil pressure is generated by the follow piston, that is hydraulic converter, and proportionate the auxiliary. Basically, this secondary oil pressure goes to pre-control valve, and by fulcrum, this secondary oil pressure will be open close. Slide down. We'll see here directly. Secondary oil pressure comes from here, and the control oil, basically this is 32 kg bar pressure will be there, and the filtered oil, and this will in turn operate the control valve opening and closing. Thank you. Thank you, sir. Any doubts?
Thank you, sir. Participants, if you have any questions, please you can ask. Any case studies?
Adebaji, thank you for your nice presentation. Really, it was a very good class session on the turbine governing system for the understanding purpose. Yeah, thank you very much.
Thank
Now,
you, sir. Thank you, sir.
yeah, now there will be session from NTPC Kota. Miss Shardananda will present the case study from their NTPC experiences. Now I hand over the session to Miss Sharda, please.
Thank you, sir. Sir, I'll be needing privileges for sharing my screen.
तो मैसेज किया कि जल्दी जल्दी कर दो.
A very good evening to all of you. Actually, it's a very short presentation, and I'll be just sharing some case studies. If I'm not audible, please let me know because there's a lot of background noise over here. I'll be yelling a little more.
No, it's very clear, sir. Clear, madam. You can continue.
So basically, I have there have been several problems that we have faced in the governing system. I have been associated with our version 1 machines of 200 megawatt and 500 megawatt with 4 volts, and I've also been associated with 500 megawatt machines with 2 volts, the newer versions. So this particular case study with where the IP stop valve, the interceptor valve was not opening, that belongs to the 500 megawatt, the new fleet of machines, which was installed in Unchahar. Now it so happened that the unit had tripped at that time, and while reviving the machine during ATRS, it was found that 3 of the 4 stop valves had opened, but one stop valve, that is IP stop valve 2, it did not open at all. Now we went downstairs in 8.5 meters. We tried to open the valve through our test valve, but even manually it did not open. Then we tried several things, out of which one of the thing was that there's a solenoid valve which is meant for ATT, which is installed in the wall block assembly. We tried to we replaced that also, but still it did not open. The trip oil pressure below piston, it still remained 3 KSC, which is not at all sufficient for opening the valve. Then we opened the wall block assembly, we opened the test valve and the ATT valve. We checked the clearances between the test valve and the ATT valve with pilot valve with the liners. It was all okay. Then we tried to find out whether there was some kind of a drainage in the system due to which the trip oil was not generating as per design. It was very low. So we tried to pinpoint exactly where it was happening. So we started, dumbing the lines in the middle between the test valve till the just 1 second. Between the test valve and the stop valve, and we found that once we dummied it before the stop valve, the test trip oil pressure was sufficient. That means there was some leakage within the servo motor. And just the presentation before mine, there was shown this particular slide was shown. I'll just tell you that in this thing, in the stop valve servo motor, it's the same for all kinds of 200 megawatt or 500 megawatt. It's all the same. In order to open the valve, I want trip oil pressure to go from here to push this bottom plate to the piston and open the valve. But if there is some, some place by which this entire oil can be drained, if there is a short circuit of oil through and the trip oil that comes over here gets drained from here, then there is no other option. Then your stop valve will not open at all. Your spring will not latch. So we tried several things, but it did not happen. We found out that there's a problem between the servo motor itself, and so we opened the we replaced the servo motor. We got a spare servo motor from Dadri, and we replaced the servo motor. Unit was also recommissioned. When we dismantled the servo motor, it was found that there was a material chip. There was a small piece of material that was chipped off from this piston. See, you see this end of the piston, no? Right at this point, and the bottom plate, there should be a line contact. But there was a 20 mm piece that was chipped out of it, due to which there was no contact between, there was that entire area had no contact. So that trip oil was getting drained through that area. It was getting drained into the drain port. And when we replaced servo motor, it was fine. It worked fine. So now we spoke to BHL Haridwar. It was a newly commissioned machine. And BHL Haridwar found that it was a material problem in the servo motor itself, and they have replaced it. My second case is regarding HP control hunting. This happened in a version 200 megawatt machine. After capital overhauling, the turbine was on soaking speed. There was no problem. Then the turbine was rolled to 3000 RPM. Immediately upon reaching 3000 RPM, the HP control valves had wide variation. And that caused the turbine speed to vary and reach critical speeds. Immediately, we tripped the turbine. Governing filters were the first, line of defense. We cleaned the governing filters, but still this problem persisted. After that, we saw that there was a wide hunting in the auxiliary secondary oil pressure, and which gave way to the fact that the machine was in hydraulic mode. And why should the auxiliary secondary oil pressure have hunting? That's for that reason we tripped the machine. And then you see in the hydraulic speed governor, there are two auxiliary follow pistons. And these two auxiliary follow pistons should be perfectly balanced. Otherwise, there will be some variation in the auxiliary secondary oil. How do we check that? We took a pressure gauge and we put it in the assisting line of the second follow piston. And we found that the two pressures were not balanced. We balanced both the pressures and then everything was fixed. But the question is that, why did this happen? Why were the two pressures not balanced? Generally, when we are setting the auxiliary secondary oil pressure, we tend to use only one follow piston. We get the pressure and we forget it. But in future, whenever we are going for governing characteristics, we should make sure that there are two pressure gauges which are installed in the in both the auxiliary follow piston lines, and both the pressure gauges show the same pressure. If that is maintained, then our auxiliary secondary oil will not have any bearing on the AHC mode. Otherwise, if there is variation in the auxiliary secondary oil, then there will be a lot of problems which we will face. The third case study is again 200 megawatt, but this is version 1. It was in Korba itself. Unit 1 had tripped on some electrical problem, and during unit startup, the LP bypass valve did not open. All protection devices were checked. There was no problem found. We checked the filter line in the feedback oil, but that was also not the problem. The pilot was clean. That was also, and the pilot was clean, but it was not rotating freely. We replaced the bearing. The pilot has a bottom screw which rests on a ball. That was also replaced, but this still did not replace. It did not change the problem. Then somehow we revived the unit with one LP bypass valve. The unit was running, and we thought that let's try again to revive the LP bypass valve. We saw that the liner had slipped from the casing by around 15 mm. Now see, there is a screw that is placed in the liner that is between the casing and the liner to keep the liner in position. And the screw, we saw that was out of the casing by around 10 mm, whereas it's supposed to be 6 mm inside the liner itself. So then we fabricated this fixture. We fabricated this fixture, and then we, using jackboards, we lifted the liner. You see, this liner was slipped over here. We lifted the liner back into its position, and we tightened the screw. Once we did that, the pilot started rotating freely, and we had no problem. So these are the three experiences that I wanted to share. Although I have several such experiences, but due to the want of time and all, I could just formulate these three into a presentation. If you have any other doubts, we can just have a question answer session.
Thank you, madam, for the nice presentation of the case study. Is there any question, please? Okay, madam. Thank you very much.
Thank you, sir.
Now there is the presentation from the Singareni Power Plant, Telangana. Mr. Vishal Ladha will present the case studies of his plant. Hand over to Mr. Vishal.
Yeah, thank you, sir. Sir, please give me screen sharing rights so that I will share my presentation. Host, please enable my screen sharing rights. Okay, thank you. Is my presentation visible?
Yes, sir, it is visible. Please go ahead.
Okay, sir. 1 minute. Good afternoon, all. I am delighted to stand before you today to deliver a presentation on the fascinating and highly relevant topic of turbine governing system. Particularly in the context of our online workshop, this workshop aims to shed light on the intricate and critical mechanism that govern the operation of turbines, which are at the heart of power generation in our modern world. Governing system, we all know governing system is the heart of the power plant. So I will present you in my presentation in next slides in PDF mode only, and this is a case studies. So I will present you 4 to 5 case studies that we faced. First one is about unit 250 megawatt. The unit could not be taken into ESTC mode due
Can
to
you please
hunting.
magnify, sir?
1 minute.
Yes.
Okay, is it visible?
Sir. Yes, sir.
Okay, so the unit could not be taken into ESTC mode due to hunting. Hunting means if our command is 50%, position set point is 50%, but collision transmitter or Belloof transmitter feedback is continuously hunting. Secondary oil is also hunting. So the ESTC position feedback was not exactly following the position set point. The trends are attached for reference. We will discuss about trends. First, what was the root cause and what we did to rectify the problem. So when there was decreasing command of ESTC position set point, Steadily, the actual ESTC position was seen decreasing more than required value and raised back to means the command and feedback is continuously oscillating to follow each other. Means command is following feedback and feedback is following command. This continuous behavior caused hunting as the unit was in service only in hydraulic governing mode operation. So this is our line of act. First, initially we suspecting the problem was due to electronic system. The following has been replaced. So in electronic, everybody knows if this problem arises, first doubt already goes to C&I department that your electronic system is malfunctioning. So C&I proves that plunger coil, colon transmitters, colon transmitter module, this is non-max card. AKC, everything they had replaced. The cable from field JB to CJG02. CJG02 is nothing but ESTC panel. So they replaced all the electronic modules, but the problem is remains same. The pilot wall of ESTC was also cleaned. One went provided to the plunger ESG plunger coil chamber to eliminate doubt of pressurization in the chamber. With all the above activities carried out, the problem remains same. Further following checks were carried out as per the advice of BHL PSSR during annual overhaul. The trip oil pressure inlet the trip oil pressure inlet to ESTC was reduced from 5.8 to 4.6 kg. In steady value without any pulsation was observed in newly introduced trip oil pressure gauge. ESTC pilot valve and follow-up piston were serviced again, but no abnormality was found. The orifices in the trip oil line to ESTC were cleaned and the trip oil pipeline was also air blown. Orifices is just below the auxiliary follow-up piston. So these all the orifices were also checked and cleaned, but still the problem is same. Even the plunger coil balancing voltage was also on doubt position. So balancing voltage of the plunger coil was readjusted to minus 1.10 volt after reassembly of all the systems. The ESTC characteristics were taken and behavior was smooth. So the trends of position set point and feedback are attached for reference. The behavior was normal during raising and during lowering of the set points. The unit was rolled and synchronized with ESTC. No problem was found on ESTC. So what was the conclusion? The conclusion is very simple. The root cause of the problem is suspected to be higher trip oil inlet pressure to ESTC. This has caused the pilot response faster and more than required and made the ESTC converter movement again corrected position to the required position during internal draining in the pilot valve. The actually these all Mr. Hadi Abbas sir and Mr. KV Vidya sir told you the actual architecture. You just compare this situation to actual architecture what was explained earlier in earlier sessions by Mr. Hadi Abbas and Mr. KV Vidya sir. So the recommended pressure of triple pressure at ESTC inlet is 4.5 to 5 for smooth operation of the ESTC. It is at inlet of the ESTC. This is not a triple pressure, triple header pressure. This is the inlet pressure that was attached, or the correction point is also just given below the ESTC points where auxiliary follow piston is present. So this is my first case study. In this situation you just see this line is blue line is position set point, but ESC position is continuously hunting. Then after work done, you just see both trends are at the same place. This is ESTC position, ESTC commands, and now you just see here command is following load control output, speed control output, everything is following, and this ESTC behavior after rectification set point raised. So next is feedback number 2 is random tripping of HP stove valve left after loading. It means this is a 500 megawatt case study. In this case study, during the first commissioning trial of the unit, the HP stove valve left side was tripping randomly after unit was run on load. This happened a couple of times at a different load and parameters. So after tripping of stove valve, turbine was not tripping because to trip the turbine, both stove valve has to close or triple pressure zero. This happened a couple of times with different load and parameter, but it did not cause any turbine tripping. It was having potential for turbine tripping, so it needed to be attended. So what was the analysis? What was the line of actions we did? Following pages contain images of HP stove valve coupling with details. When the you just this is a purely mechanical situation. You just check when the stove valve is closed. The status of the coupling parts is shown in schematic diagram 2. I will show diagram 1 and diagram 2. When the valve is opening under hydraulic forces, the status is in drawing 2, figure 2. When this valve is fully open, the status is this. The status is just like that. When valve is in fully open condition, when valve is a closed condition. So the here is the gap. You just check the arrow mark. The extra material growth has found in this area. So the coupling gaps indicated in the design drawing shown ensure there is a provision for thermal growth of the wall stem when hot steam is passing through the wall. If the assembly of the coupling does not follow the gap dimensions, then tripping can occur. When thermal expansion of the wall stem pulls down on the servo motor stem and causes release of triple flood pressure. So the this will happen every time when even then in my 600 megawatt at Singrani also this was happened before some days. Walls servicing was not done 3 or 4 years. So thermal we found thermal growth, and due to that thermal growth continuously IV2 was continuously tripping at any further of time at any time of the load. So what we did here for analyzing this, the coupling gap was checked in the closed condition and found to be only 6 mm instead of 7 mm. Then a 1 mm seam washer was inserted between parts 35.1 to 35.2. At drawing 1, no tripping was observed. As a permanent correction, the coupling part was machined by 1 mm to the location of BB. Here just you just see 35.2, and at the BB position here is shown the machining was done because 1 mm difference is only 6 mm, so it should be 7 mm at open and closing condition. So this first of all to run the unit, we just inserted the washer, and after in overhauling, just machining was done. The problem was resolved as explained above, but some improvement is suggested or future set. The machining that was done was a necessary correction because the provision of thermal expansion of the wall stem found inadequate. It is better to have the dimensions tolerance for individual component ensure at the unit so that product menu. This was the conclusion given by BHL persons. So this is the two case studies in ESTC. Now I will show you third case study. Yes. This is for unit 500 megawatt hunting in ESTC during calibration and could not be taken into service during first commissioning. In the view of design, yes, the moving coil was replaced with proportional valve. In 2012, the moving coil means plunger coil. Initially, in LP governing system, plunger coil was introduced by BHL. Then, after some period of time and some modernization and for fast governing system, they replaced the proportional valve with this valve by BHL Haridwar. The first of this kind in PSS were commissioned at Simadri Unit 3. The proportional valve receives the signal from ESTC through the amplifier module. Two stages of position control are used for operating the steam turbine control valve. Just I am showing you the architecture of this overall drawing. First, ESTC position set point that we can see on our ESTC page. This ESTC position set point is directly giving command to the analog output card. Analog output will 4 to 20 will give command to ARS card. This is non-max card. ARS card is taking feedback through position transmitter transducer, and it is giving command to the amplifier module. That is this amplifier module is again giving command to the proportional valve, and this proportional valve is giving feedback to the amplifier module. So here we have two loops. One loop is through ARS card, another loop is through amplifier card. Two loops has been introduced. Two loops were introduced in recently 2012-2013 modification by BHL from plunger coil modification to proportional valve modification. So on in the place of Colin transmitter, they used Belloof feedback transmitter. In first stage, demand signal from speed load control is compared with the ESTC position through Belloof, and the difference is amplified as differential input command to amplifier module. And in second stage, through the amplifier module, they are actually giving command to the proportional valve through inductive position feedback transmitter and compared with the externally applied command value. Any difference between that automatically give command to the proportional valve, and through that governing system is operating like that. This is the proportional valve system. This is servo coil. This is LVDT, and this is Belloof transmitter. That in 600 megawatt JPL Tamnar also same, DB power also same. This same in 600 megawatt of BHL is same unit, and these same components given by BHL. So analysis and troubleshooting, all the troubleshooting feedback received from the other region side having the proportional valve were taken care and incorporated at site. The same are listed below. Amplifier module and capacitance module are housed in a JB, and the JB is erected very near to the governing rack, less than 5 meter. Before it was away from the amplifier module. Power supply to capacitance module and supply to enabling signal is also taken care, and it is electronically earthed. That is a very critical point. Electronically earthed. If it is not earthed, then hunting can be observed. Voltage measured at the capacitance module is also 25.9. Third thing need to be take care. Three co- uh, three core cable 2.5 square copper cable is used for power supply, and it is isolated from signal cable. Command signal from ESTC cabinet is 20 to 4 with respect to 0 to 100% command. And the fifth point is also very critical point. The command signal from ESTC was terminated in terminal board mounted in ESTC JB. The same was wired to amplifier module, the servo and LVDT, and these all should be taken care, because the shielding, if even then initially BHL has introduced a metallic JB, then through this metallic JB some hunting was observed, so they replaced the metallic JB with fiber JB, and later individual cables have been laid to the solenoid supply and spool position feedback amplifier box. The ESTC converter piston and linkage to follow pistons were inspected for any sticking in order. In spite of all these modifications, the hunting still persisted. All the feedback which other sites are following we have taken, but still the hunting still persists. So now BHL Hagar supplied a new proportional valve and the same was mounted. But even after replacement of proportional valve, the hunting with the humming sound still persisted. The representative of Rexroth also visited site to study the problem along with engineers from Haridwar and EDN. The proportional valve was dismantled and checked for any foreign materials found in order. The wiring from the terminal board to the amplifier module were bunched and dressed together in cable trays in JB. This is the modification after they came to the site. And this was resulting in interference between the solenoid command cable and the LVDT. Yes, this is the reason. This was resulting interference between the solenoid command and LVDT cable. That this is from JB to proportional valve. It was also seen that the terminal block in junction box of the governing rack and terminal block in the junction box of the amplifier unit were forming multiple junctions in the signal path for command and feedback. The following modification were done. These 5 modification were done. You just check this JB. This modification was done. What modification? 2 independent shield cable with conduits for proportional valve solenoid and LVDT portions were laid from amplifier unit to the proportional valve. It was observed that while connecting the solenoid cable shield to Z terminal of the amplifier, fault signal H1 is initiated on the amplifier module. This is H signal. Here is a fault signal. This is a H1 signal. This is produced. Null point adjustment of proportional wall and amplifier module will carried out. From this calibration port, null point was adjusted. The operation was checked by varying the demand signal step by step from DCS. Now no hunting observed. So these steps, these need to be take care at any station, because nowadays hunting may be due to oil quality also, because our proportional wall is very delicate due to moisture and oil quality. So if hunting is observed, first we need to check oil quality. If oil quality is okay, moisture is okay, then we need to consider on shielding of the proportional wall, shielding of the amplifier module, and then need to be check cable noise also. So all the things need to be take care, then definitely hunting problem will be resolved. And after that modification, the rpm and all are smooth. So this is all about ESTC case study. Now just I will show you TDBP case study. TDBP, in TDBP also has some governing principle, and in TDBP one we face some problems. Insufficient triple pressure build up for resetting trip device, and hence the stove valve could not be opened. I2H means current to hydraulic converter of auxiliary control valve, not responding to the current and secondary oil pressure, could not be varied even with the manual operating knob. Main control valve not operating consistently with secondary. These all three things we observed. So what was the reason? Insufficient trip oil pressure build up, and hence stove valve could not be opened. For resetting the emergency trip gear, tripping device located in front of bearing pedestal, speed governor tester lever was manually pressed and released slowly. Trip oil pressure buildup was less than 4 kg, and on giving command for stove valve open, it did not open. To improve the triple pressure, the lever of the speed governor tester was kept manually pressed down, and stove valve open command was given. The stove valve got opened. After full opening of the stove, the lever of the speed governor tester was released and found again stove valve tripping, because manually we are pressing the overspeed device. That is why triple pressure has built up and stove valve opened. But after removing manual interface, again it got tripped. So corrective action were taken. First corrective action, overspeed governor tester. This is OTT. In the governing console was dismantled. For servicing, it was found that lever linkage mechanism pin got damaged. It was replaced. Debris was found inside the block. It was cleaned and assembled back. Turbine trip gear was also dismantled and found that control slide was not moving freely into sleeves. Trip gear hand lever was also unable to move the control slides. Clearance between control slide and sleeve was very less. Clearance was increased by polishing the control slide with fine emery paper with the help of mechanical team. The trip oil outlet flange from tripping device in front of bearing pedestal was found having restriction caused by insufficient hole cut in gasket provided at site. After these all corrective action, the trip oil build and the tripping mechanism were normal. Stove valve opened smoothly. I2H converter of auxiliary valve not second problem. What was the second problem? I2H converter of AGV, auxiliary governing control valve, not responding to the current and secondary oil pressure. During stroking of control valve, it was found that I2H converter of AGV was not responding to the current, and even in manual mode with operating with knob, the pressure are not responding. So what action has taken? On thorough inspection, it was found that the drain port of the block for auxiliary control valve was not through. The block unit was replaced from other TDBP, and the auxiliary control valve was stroked satisfactory with I2H. Now the second problem is also resolved. Third was main control valve not operating consistently with secondary pressure. Pilot valve was dismantled, and it was found that pilot piston was very tight, and it was tried to take it out, but only 30 is coming from freely. Then it is very hard to move it. It was taken out, and pilot piston from TDBP Agra was taken and assembled into pilot TDBP emergency work. it was free to move. Again, valve stroking was done. It was observed that the main control valve was operating to full range with small pressure increase. It started operating at 1.5 and full open 2 kg. Adjustment could not be achieved as per characteristic. Uh, so it was decided to change the pilot sleeve and pilot piston together from TDVP assembled after cleaning the servo motor of TDVP Bombay. During wall stroking, it found that wall starts opening at 1.5. Now it is correct 1.5 to 4.50 to 100%. It means a problem was with pilot sleeve and pilot piston, because pilot sleeve and pilot piston was not having much more clearance. That is why it was not operating in within range. So TDVP governance system are thoroughly inspected, cleaned. The governing component also taken in service. These all are about the governing system case studies. Thank you, sir. If anybody is having any doubt, please can ask.
Thank you, Vishal.
Thank you, sir. Thank you.
Just a minute. Is there any query? Yeah, really, it was a very good presentation by you, and really it served the purpose of our workshop
Yes.
about the case studies and difficulties or challenges we faced in our working life. And I think it will be very, very helpful to others also, that about this governing system rack, this DB power, Tamnar also, they may verify their system with this modifications, whether they are done properly or not. Yeah, definitely. All the case studies are presentation what which are this presented in this workshops will be shared all the participants. Yeah. Okay, thank you, Vishal. Now there will be the questionnaire session or discussion session. Now the formal presentations are completed for the day. Now we'll go for the discussion. I request from delegates from Adani, DB Power, as well as the RKM for sharing their experiences. Need not to give the presentation, only they can share the experiences, what they faced in their working life, as well as what they expect from the this forum also.
Sir, one observation we have found in the IP control valve, after tipping for short shutdown for BTL, we observed the IP controller not opening through the DCS. So after that, we could find that the ATT servo motor, ATT motor, when we were just operate by hand, so it could be possible, could be thoroughly 100% open through the ATT gear motor. So if you stuck some position, so it will not through the second valve, it will not open the IP control valve. So after that, due to panic, somebody so we have checked why this is not opening the IP control valve. Then afterward we have found that the ATT motor is we have not some after during the shutdown we check the ATT, but not thoroughly open the 100% open the ATT motor. So the gear stuck the open for to which obstruct the opening the valve. So after manually open the ATT and gearbox to ATT motor, and now after smoothly operate the valve. So one problem, another problem, same thing what we observed in synchrony, and the IP stop valve could dent some instantaneous, because this is happening due to the clearance of the coupling. And for temporary, we have put the seam accordingly the clearance, and after the solution finally is the machining the coupling for the required gap to be maintained. So same problem also happened in the at Adani Raigarh also. And the second is the instantaneous for the IP control valve opening. And meantime, in the hunting problem may be occur, but it could resolve through the instantaneous. It is resolved sometimes is the plunger coil problem and tightness the coil. But otherwise, what we just discussed about the other the plunger coil and the ASTCs or the JBs, there is a some short earthing problem is something is there, so we could take care now in our side. Thank you, sir.
Thank you very much. Really, this turbine governance system is really peculiar and complicated, and these experiences serves a lot to improve our systems. And what is it that this ATT system is sometimes very troublesome, or it makes more complicated to the governance system. There are so many case studies are there that ATT solenoids and that ATT systems create problem in the governing, and because so many problems there. That is not reverse. Yeah, that right. That motor when we couple the motor, that is very important. How we are coupling at which position we are coupling. Yeah, in my personal experience also, we have faced so many problems due to this ATT motor coupling after the overhauling inspection. Is there any question or share from online friends? Yeah, definitely this session really it is I think it will be useful for us, and we will gather all the presentations, case studies, and we will circulate to all all who are present in the hall as well as the online. For that, I require support that you should give the feedback properly. We have shared the feedback form online also. And we request all of you to give the feedback, and also we require feedback to improve our system. How we can improve this monthly forum.
Send the contact details of concerned person of each station. So in case of any emergency or in case of any doubt or any queries, we can contact among each others.
Thank you, Anirbanji. Definitely this this forum may help us to form the community of or functional communities, and that's why we require just like suppose this workshop is for the turbine governing. Then C&I as well as the turbine maintenance persons are involved mostly in that workshop or this works. And I request all the participants to share their turbine maintenance and C&I persons contact numbers to us, and we take this responsibility to circulate to all the participants. Thank you for the nice suggestion. Any other suggestion, please? Now we will go for the concluding section, and after that there will be the there will be the plant visit. I think it will be very useful to host plants, means to us also, and to the delegates who are visiting to our plant also. Now I request our Jhore sir, or head of the institute, for the concluding session, please.
Hello, sir.
Yeah, Vishal, please.
Sir,
Yeah, please speak.
Just now, sir, one in ESTC, I want to just share one more case study. Just before 5 minutes in the Jindal India thermal power, वहाँ पे एक problem just now आई कि
Yeah.
running
Welcome.
unit was running at 600 megawatt. Unit was running at 600 megawatts, sir, and suddenly one stove valve closed. IV stove valve in running condition. So operation people went to field and they just doubt on a solenoid of ATT solenoid. So they removed the solenoid and oil leakage was there. So to attend this leakage, they stop the machine, and now they are going to open the stove valve, but no stove valve is about to open. All the stove valve in closed condition. This same problem before 1 month, I think, has faced in JPL Tamnar also. So we just I have given some feedback to that. Or if anybody has any feedback about that, I just told them ki just close all the test valve of all IV and SV test valve and just open one by one test valve, and you will find oil is draining at some test valve position. So you need to replace that test valve. Unit will be fine. So this was my feedback. If anybody is having any feedback, just share with me. I will just convey to them.
Is there any observation from the forum? Yeah, Vishal, the same observation I have also faced in my earlier plant also, that this ATT system is very troublesome. The solenoids and these fixtures, they create nuisance in the system. So
Yes.
many times. Yeah. That leakages and all these things.
No, you are talking of the liner clearance for test valve?
No, liner clearance. Just we need to just isolate one by one why stove valve is not opening. So we need to isolate all the test valves, and one by one we have to open, and we need to identify where oil is draining, because now all this trip oil is same, everything is same. Secondary oil, starting device is also working, but stove valve is not opening. Even startup oil is getting zero, but trip valve is not opening. So we need to isolate one by one test valve, and we need to check which test valve is having problem.
Okay, if I found some draining through one test valve, so what will be the remedies?
Then we need to replace to run the machine. We need to replace and service the test valve.
Means test
You
valve.
can replace the liner also.
Yes.
Yeah, that's-
Liner in the test valve, na?
Yes.
Yes. Okay.
Actually, we have to check that through which the test valve draining is going on, so that accordingly we take care for the liner
Yes.
replacement or not.
Okay. Okay. Thank you.
Thank you.
Yeah, is there any feedback about the problem? Okay, Vishal.
Okay. Thank you, sir. Thank you.
Yeah, we will discuss after on that subject. Huh?
Okay. Sir.
Now I request Karthikeyan sir to for further proceeding.
Good evening. Thank you, one and all, for your effective participations. I also thank these delegates for presenting wonderful presentations and sharing the interesting case studies. And I hope this would have given you a lot of learning, and this experience sharing would have been much useful if the same problem is experienced in the similar kind of units. And definitely these learnings will be valuable, and it would definitely give an opportunity to address the problem in a very better manner. Right. With these few words, now I would like to request our head of the institute, Mr. Munish Jawhari, to give gifts to the participants. May I ask the participating participants from various organizations to come one by one and to receive this participation gift. May I ask Mr. Tamnar, ना first JPL करना चाहिए, ठीक है. DB Power, Raigarh. I request these participants from DB Power, please come on stage, please. Thank you, sir. Give a big clap. Next, Adani Power. Participants from Adani Power, please come forward. Participants from RKM Power, please come. Sir, JPL. Sir, Sudeep Gyar, sir, from JPL. Now, I request our head of the institute to give a valedictory speech.
थैंक यू. आप सभी लोगों का जो डिफरेंट स्टेशन से डीबी पावर, आरकेएम एंड अदानी से आए हैं, अदानी रायगढ़ से, या जो दूसरे स्टेशन से लोग जो हमारे जूम प्लेटफॉर्म पे कनेक्टेड हैं, आप सब लोगों का सबसे पहले तो धन्यवाद कि आप सबने इस वर्कशॉप में पार्टिसिपेट किया और गवर्निंग सिस्टम्स के बेसिक्स से लेकर के जो ट्रबल शूटिंग्स तक की जो केस स्टडीज हैं वो सब हम लोगों ने यहाँ पे आज डिस्कस करी, और इससे सभी लोग जो भी इससे कनेक्टेड रहे हैं वो तो इससे उनको फायदा मिलेगा, एडवांटेज मिलेगा, बट ये चीजें जो है हमने YouTube पे भी अपने चैनल पे स्ट्रीम करी हैं, एंड इट विल बी अवेलेबल ऑन दैट चैनल, so it will be further useful for the masses. So that is one thing. So once again, thank you all of you for participation. दूसरा है, in addition to this initiatives where we are organizing workshop every month, we have started another series where we will be having the meetings of the HODs of different domains. Recently, we had a meeting of HOD C&I, which was organized in Tamnar, where all the HODs of the C&I in the plant's vicinity, or even plant as far off as Singreni and Prayagraj, have also joined this HOD meet. In the similar fashion, we are going to organize HOD meets in different other domains like boiler, turbine, electrical, ash handling, coal handling, or coal sourcing and things like that. And we have already written to all the HOPs for that, so that these HOD meets can be organized in the different stations, so that we will have the facility, or we will have an opportunity to visit the different power plants and learn from their working culture, their whatever the establishment they have for the successful O&M of these plants. So there will be a lot of learning with that. So for that, we have already written to all the HOPs of all the stations. आप लोग जो इस प्लेटफॉर्म पे कनेक्टेड हैं, आपसे मैं रिक्वेस्ट करूंगा कि आप लोग अपने स्टेशंस पे अपने HOP से डिस्कस करके किस डोमेन से रिलेटेड मीट वहां पे आप लोग ऑर्गेनाइज करना चाहेंगे, वो हमें कम्युनिकेट कर दें, और प्रेफरेबली किस मंथ में वो ऑर्गेनाइज करना चाहेंगे, बिकॉज वी हैव अ प्लान टू डू वन मीट एवरी मंथ इन वन डोमेन. सो आप लोग अपने HOP से बात कीजिए अपने अपने स्टेशंस पे, और जो भी डोमेन आप लोग चूज करना चाहें उस डोमेन को, और कब आप प्रिफर करेंगे, हमको कम्युनिकेट कर लें, सो दैट हम एक एनुअल कैलेंडर जो है इसके ऊपर में रिलीज कर सकें. ठीक है, सो दैट इज व्हाट आई वांटेड टू रिक्वेस्ट यू, एंड वंस अगेन थैंक यू ऑल ऑफ यू फॉर participating in this workshop, and thank you our JPL Tamnar team and our students who have joined this program.